All right, it says we're live. So, hey everyone, it's Ellie in Space here, and I am joined by Scott Walter, who I've had on the channel many times. He's, a rocket scientist, whatever. And we also have James Douma for the first time. You're described as a deep learning dork,
Yeah.
at least on your Twitter.
Self-described.
Self-described.
Yes,
Yeah.
but maybe, self-described. But maybe tell us a little bit more about your background for people who are just meeting you.
Boy, where do I start with that? So, lately I've been talking a lot about Tesla's AI and machine learning efforts on YouTube, and I think that's probably where I come from. But my background is I'm just an overall engineer. It's I taught myself circuit theory because I needed to put food on the table after I dropped out of college, and so I started designing electronics. I've worked in an electric car company. I've done all kinds of stuff. It's I did software for years and years. Physics was my first interest. Computer science and machine learning was something that I wanted to do in college. This was before the second AI winter, when neural networks first started taking off, but it wasn't something you could make a living at the time. So I got into other things. I became an entrepreneur. I started some companies. I got tired of corporate life. I dropped out. I started investing. That turns out to be a really easy way to make a buck. So that's kind of what I've been doing since then, right? And
it's an easy way to make a buck.
Yeah. Okay. In terms of the amount of money that you make for the amount of time that you put in, that's just you have to start with some capital,
right?
And you have to be patient. You have to figure out what you're doing, but invest compared to being a working engineer, man, being an investor is a piece of cake. And that is the amount of money you make for the amount of time you put into it. It's like no contest, right? Like being an investor is much easier.
Clarify, you said you had some time with an electric vehicle company, but you've never worked for Tesla, right?
No, I haven't.
I mean, you might as well, because you're talking about FSD on every freaking
I think of myself as working for them without getting paid.
Yeah. And I think it's really interesting because if you search James Douma on YouTube, you're going to see tons of FSD stuff, some Tesla bot stuff, Dojo stuff, but you're always wearing a SpaceX shirt, and yet no one really talks to you about SpaceX. So I wanted to, ask you some questions about your love of space as well, because I feel like people don't really get to see that side of you. So we can talk about other stuff too if you want, but I feel like you've probably been
what you think will be interesting? I'm up there.
Yeah. Well, and obviously, we're Ellie in Space. So we love space. We want to talk about space.
we have one thing in common. I'm 3 hours away from Kennedy, and you're about 3 hours away from Vandenberg.
Yeah.
Right.
I can see SpaceX launches from my backyard. So Karen and I, we go out to Vandenberg every single chance we can. Like if there's a launch and we can make it, and there's any chance that I will, because Vandenberg fogs in a lot, and so frequently you can't see stuff. But it'll work for us. We get in the car and we get in the car and we go. But at some point, I was trying to figure out, there must be some place, because it's only 100 and it's under 200 miles away. So there must be a way to see it. When we actually were there at the launch, there's a couple of years ago, 2018, was it 2018 launch? The one where it had the big squid and everybody in LA saw it and they thought it was a UFO or whatnot. Well, we were there under the rocket, shooting video of it from the ground, and it looked really different if you were at Vandenberg, because you're looking at the squid from the tail end instead of the big thing that's out there. But I got Google Earth and set up so that I could go all along the mountains and whatnot near where I live to try to figure out where's there, because I live at the base of a range of mountains, the San Gabriels, and so the sight lines are restricted by how the terrain is shaped, and I was trying to figure out how you could get a straight line of sight to the horizon where Vandenberg was, and there aren't that many places near where I live, but it turns out that one of them is my backyard, right?
Oh, wow.
You can go up the hill at the back of my yard. Like there's this little ridge I live right at the base of, and it's only like 200 feet tall, but you can walk up to the top of that ridge. And if you know exactly what direction to look, you can see the horizon. And I've done that, when I couldn't make it out there, I could go, at 6 a.m., stand up on the ridge behind the house and then watch the rocket go while you're, on your phone listening to the podcast. It's really cool.
But you're originally from South Texas, right?
Yeah. I grew up down near where Starbase is, right? I grew up in Harlingen, Texas.
Have you been to Starbase?
I have. Yeah.
Okay.
In fact, I hadn't been back to my hometown in 30 years, and Starbase was the reason I went. So, yeah.
Wow. So I feel like everyone on my channel is a Starship fan. So let's get into your thoughts about Starship and how closely, obviously, I'm sure you've been following it. Yeah.
It's going to be a revolution when we get it, which I think is probably going to be pretty soon. Now it seems like they're making really good progress, and I'm super excited to see it finally fly. I think everybody is. Yeah. We're hearing maybe December now that they'll get it off the ground. That's going to be one of the best things ever. I was alive when the Saturn V flew, but I was nowhere near where the Saturn V flew from, and I never got a chance to go see the shuttle, but I think that watching Super Heavy take off with Starship on top of it is probably going to be the most amazing sort of rocket thing anybody's ever seen in real life. Yeah. And I'm really excited about the possibility of going there to see that. So
probably as impressive as Falcon Heavy, right, Ellie?
Yeah, we got fogged out.
Yeah, I saw. That's too bad. Stick in there. Go back. I would so love to be close enough to the Cape to be able to go see a Falcon Heavy, because watching those boosters come back would be so cool.
Well, I flew all the way from Portland, so I'm not exactly close. And then we got
I probably would have had a better view from my backyard as well, because I'm the same distance, so like 150 miles. And I do the same thing, because I don't have to worry about mountain ranges in Florida. So I don't need Google Earth. I just need Google Maps and can line that up. And see it, and then it's like, well, I drove 3 hours to the Cape for nothing. We had the closest seats in the house, and we're the only ones who didn't see a thing.
It's like that sometimes. So Vandenberg is like that too, where like the fog is it only extends in a certain distance from the coast. So if you're a little farther away than that, you get to see the rocket. But if you're there at Vandenberg, you don't get to. Or you can go up. There's some hills nearby that are pretty tall, and I know that the people who are the old hands of going out to Vandenberg, who like know all the secret spots to watch this stuff from, they know where there's spots that are high on nearby hills you can get up and put your cameras and whatnot. I've seen photography from those locations, but like nobody let me in on the secret, so I haven't got to go there. But the cool thing about Vandenberg is that if you go to Ocean Boulevard, you're only 4 miles from the launch pad, which is much closer than you can get at the Cape. Now, the reason you can get that close is because the launch pad has a low rise between it and so the thing is, if it blows up on the pad, there's a hill between the rocket and all the people on Ocean Boulevard. But being 4 miles from it is pretty cool. And then they have a landing zone there too. So if you manage to go for one, occasionally they'll have one that comes back to the landing zone. Like mostly they fly Starlink out of there. And Starlink, they pack it to the gills, so they never have the reserve fuel capacity to fly back to land. But occasionally they'll do a commercial satellite launch out of there. They'll be able to bring it back, and then you're like, you can. It's pretty cool. Like I went to see one there. You can follow it naked eye, like even in the day. Like you can see it go all the way up, and as long as you don't take your eye off of it, you can see it do the separation. You can see it flip around backwards, fly back, surf in on the atmosphere, and you can watch it come down. Like it's so cool. It's really great. Wow. So we're dying to get another one of those so we can go do that again.
Have you ever been contacted or recruited by SpaceX or Tesla?
Mm-mm.
No.
I don't need a job. They're probably wasting their time calling me anyway.
That's awesome. So Scott, you had thought of some questions because we've been, trying to prepare about related to Starship for James. So
I got a couple. Then I have a fun thought experiment. We'll do it just a little bit. I'll wait for people to come in the live stream. But the first thing was the thought is that I think it was an SN8. That was the first Starship that they tried to land. And I remember seeing on John's channel just before that he thought they were going to nail it because he thought that they had the control algorithms down because they had done a lot of deep learning, that they were using a lot of neural nets. And that's the first time it occurred to me, is the control system based on neural nets, or is it your classic kind of control? Because I would have thought it was your classic avionics control system in there. So could you think of where AI could be actually used?
So there are lots of little places that you could potentially toss a neural network in there and make use of it. But I don't think that they're doing control with a neural network for that. Like it's, if you look at the strengths and weaknesses of using, conventional control versus using a neural network, it's not a good match right now for doing Starship type stuff. I mean, you need to capture a lot of training data for one thing, once for things where you don't fly it a lot, if the kind of control you're doing is going to be the kind of thing where the input and the output are the kind of data that you want to capture from the real world, but you can only get it on a flight. Well, you're not going to be doing that today because it's too hard to capture the data. So I would guess it's all conventional control. The other thing is that because of the sort of risk reward trade-off for doing these kinds of things, the amount of engineering time that you put into it and the provability of the solution that you want to have, like the black box nature of neural networks really works against you in like these aerospace situations where you've got these one-offs and it's $100 million thing and everything is really close to the margin. That'll change in time. And there, like an example of where you might want to use a neural network is, when they land, they have a radar that looks down that tries to identify the pad. And, that's how they locate themselves and they do their final correction as they're coming down, is they use radar off of the pad. Well, you could imagine that depending on the wavelength that you were using at and how far away you needed to get the signal before whatnot, you might have a signal to noise thing that requires signal processing to clean that signal up, early in the early stages of the landing burn when you were coming down. So in that kind of situation, you could actually go out and capture a lot of data of like, if I take this radar and I point it down at the pad and I'm at, 60,000 feet or whatever, under various conditions, how can I use a neural network to clean that signal up so that I can get more accuracy? So you could do that because you could get a plane and fly over the pad and during different, weather or different terrain or whatnot to gather that kind of data. You could do some synthetic stuff. And so that's an example of like where you could use a building block, and it would be part of, Starship or landing a booster, but it wouldn't be, the control stuff.
The control system. Yeah. I'm thinking that usually with a lot of control systems, you have a lot of parameters that you need to have in there, especially your control gains and everything. And if you don't get those just right, your control system can be a little bit wonky as far as how it's going to work. And would it make sense that if you were to simulate it a lot and going through to try to find what are the optimum control parameters to actually use before you've actually had a chance to try it out? Because usually there's a lot of guesswork in it. Because I recall that for the flight dynamics of the shuttle, some of the original flights they did with Enterprise, where they just dropped it from the 747, is because they were trying to figure out what the actual parameters were. They had a pretty good guess at what they were based on a lot of the CFD, but they really needed to know what that was. And I'm just wondering if that's something you could do early on by letting AI help you sort of train it or make a reasonable stab or guess at what those values could be.
My guess is that conventional simulation is probably going to be a big one. And CFD today is so different than it was back when they were doing the shuttle. Like you can probably for an object the size of an aircraft these days, CFD is probably so good that that you're pretty confident about what the control characteristics are going to be without having to fly it. And I would expect that that's probably true of like the booster and stuff too. Yeah,
the booster and those are a little bit easier because they're very simple kind of shapes as opposed to the shuttle where you had a lot more. So in some ways it made it a little bit easier to do your calculations. Some of those calculations you could almost do without a computer. When you have like a conical section that's coming in, you just do it the normal way. But when you start getting something that actually has a lot of protuberances and just odd angles, which a lot of aircraft have, then you have to go and really have a CFD kind of calculation.
Well, we have some questions coming in. So Jim wants to know, what will be the impact of Tesla Bot on SpaceX?
Oh, that's
a good one. So Tesla Bot's pretty useful in lots of different ways. One of the exciting things to think about is doing a vacuum version of Tesla Bot that you can put places early in space exploration and space development where you don't people are not well suited to the conditions of space, right? I mean, we can deal with 0G and there's a bunch of stuff we can do, but we're not good with radiation. We're not good with temperature extremes. And then the life support system for humans is really, really heavy. And robots don't have any of these problems. And I mean, the general specs on Tesla Bot are showing us today that they can already get approximately the performance envelope of a human being in terms of like endurance and power to weight ratio and the degrees of freedom. And in time, I think we'll get control accuracy. Like control accuracy and whatnot are probably already better on the robots than they are. So imagine, in the short run, even before you have Tesla Bot able to, take generalized instructions and figure things out on its own, you could just remote operate Tesla Bot in vacuum settings. And it's probably a big win over putting a human in a spacesuit and sending them out to do a job, right? I mean, they already do this on the space station, right? Where they have the Canadarm and they have these various sort of external manipulators that they try to use as much as possible to avoid having to have a human do an EVA, right? It's risky, it's expensive, it's complicated, it's slow to put a human being in a suit and go out there. Or a Tesla Bot, you just shove him out the airlock. Right?
Just space him.
And if something goes wrong, get another Tesla Bot, right? You're okay. Like humans aren't expendable. That's another problem. So yeah, I think that whether it's Tesla Bot exactly or the technology that Tesla Bot is going to lead to Tesla developing, I think those things are really, really going to be useful in especially the early development phases of space exploration, space development, because humans are the weak link in all these things. You look at non-manned space and you compare it to manned space, and it's a apples and oranges kind of comparison in terms of cost and risk and just. Yeah, and Tesla Bot, he kind of closes that gap, right? He lets you explore the potential of a man-rated system without putting a man in it.
Right.
You can get that stuff polished out.
Well, and didn't we hear, Scott, recently that flight that Mike Mongo is preparing for, they're going to take a robot as their like premier passenger?
Yeah.
That
is
no.
So we met a man named Mike Mongo who won a seat to space through buying an NFT. Like,
oh wow, cool.
You'd think that sounds like a scam, but apparently it's not.
It really does.
They liked so many of the people that were eligible. They decided instead of having one seat, they're going to have, it's 5, right? Yeah, it's 5. It's like space plus 5 crew or some weird.
That's right. Yep.
Is it one
plus
of the
5,
Axiom flights? Is that how?
No, it's a Blue Origin.
Oh,
it's Blue Origin, but it's with Uplift Aerospace, correct?
Yes, I believe so. And they are bringing on
it was a big secret who they were going to be like, chaperoning into space. And we were thinking it was going to be a child because why not? But it's going to be a robot. So
that sounds like as dangerous as putting a school teacher on the space shuttle, right? You're just asking for it.
Yeah, exactly.
Yeah. So that'll be interesting. Okay, so I'm trying to make sure I keep up with these questions. Brandon wants to know, the real question is, does Artemis actually orbit the moon first, or will Starship launch? So obviously we have, a set date of November 14th. I'll be back in Florida because come on, man, no more hydrogen leaks. Okay.
However, Nicole, she's gonna first have something to say about that launch, whether it goes off on the 14th anyways. So we have a tropical storm headed towards Florida.
I mean, the Starship program is designed to like provide a space capability, and the Artemis program is really, it's designed to provide a lot of jobs, right? So the objectives are really different, and you know, in a weird way, it's almost, you know, from the objectives of the Artemis program, I mean, the politically real objectives of the Artemis program, it's almost better if it doesn't launch, right, for them. So it because of the incentive system around that, it's hard to handicap, you know, what that program is going to look like going forward.
You heard it here first. It's not in our benefit to launch us.
Well, it depends on who's, you know, what you're looking at. But I mean, one of the things that NASA has done a really good job of with these programs, and it's easy to be critical of the amount of money that gets spent on these for the amount of sort of, you know, engineering return that we get, but they are keeping a deep pool of expertise and gainfully employed during this, you know, desert of manned space travel that we've had over the last, you know, couple of decades. And, you know, so you keep them busy doing something related to their, you know, that's specific to their expertise, so they don't get rusty. And so you maintain the workforce and that kind of stuff. I mean, I think there's utility in that. It's expensive, and it's super frustrating for people who want to actually see results, who want to see, you know, boots on the moon and that kind of stuff. But there's merit in keeping that workforce, you know, maintaining it and keeping it employed and that kind of stuff. And that's what Congress has done a good job of. I mean, they haven't been cost effective about it, but they've kept that capability, you know, here inside the United States, so that we can keep making some progress.
Someone wants to know, where's that question? Ron wants to know, how many launches will Starship make next year? Did I hear it was 5 or something?
Will they launch?
Do you think it's Starship or Falcon Heavy?
Starship.
Starship. I don't think anyone has any idea.
Does it go? When is it going to go?
Yeah.
I would guess it'd be a handful. Because it's a development program still. And that, I think, you know, if you look at the early stages of Falcon development, you can sort of get an idea of what they're probably going to be looking at, right? The first few were tentative. You know, you get your first Starship back, you spend a lot of time taking it apart, trying to understand exactly how the engines performed, you know, where things worked well and not. And then you make a bunch of changes for the next go. So it's going to, you know, so you take time. But, you know, they definitely are going to get to the, you know, the way the boosters are now is, you know, it's like clockwork. They go up, they come back, you know, you clean them up a little bit, you put some more, you know, RP1 in it, you send it up again, you know, it will get easy at some point.
But actually, when it comes to looking at the engine performance and figuring out, you know, the performance specs or what maintenance has to be done, machine learning would probably become really useful there, because I think you have a lot of data probably already on those Raptors.
Yeah, there are a lot of, you know, broadly speaking, machine learning can be used in a lot of places. Elon's on the record as saying that you don't use it unless you have a problem you need to solve that you can't solve another way. And I think that the state of that stuff today, you know, that's the right approach to take. Neural networks it's a lot of work to get them working. They have this black boxy kind of character to them. The development process is really different than, you know, more straightforward kind of heuristic programming, where we've got a lot of experience and we have this, you know, deep bench of tools and expertise that you can work from. That's gradually going to change, but the way that it's going to change is that we're going to develop a lot of foundation models that you can build on. Like if you want to do, if you want to build something today that needs speech recognition, you know, you don't develop it from scratch. You go get a speech recognition foundation model, which will be ML based, but you don't have to invent it, and you don't have to train it, and you don't have to collect the data. You know, it's a building block that's been developed that can be adopted into other systems that you want to use. And for, you know, 99% of applications that use machine learning, that's how they're going to use it. They're not going to go out and collect the data and figure out, you know, they're not going to do the research. They're just going to do the development. And to the extent that you can, you use the biggest building blocks possible. Just like when you design electronics, very few people who design electronics design ICs. Most of them go buy the ICs that are a good fit for what they want to do, and then you figure out how to put that stuff together. And so, you know, machine learning models will mostly be like ICs. The people who actually build their own from scratch, they'll be a small subset of the people who use and
so work smarter, not harder.
Yeah. Well, the thing is, the original Raptor was like a Christmas tree with all the sensors, and they've been taking a lot off. And you think they're taking it off because they realize they really didn't need to sense that data, or they have a pretty good idea of what's going on? Or do you think they're filling in the gaps with a little bit of machine learning?
The programming, well, they probably are filling in a little bit of the gaps. I don't know if they're using machine learning to do it. They might be. I mean, there are some aspects of like the Raptor development program where you could throw a machine learning model at some aspect of what it was doing and it might be a better alternative to a more conventional engineering approach to doing it. But I think most of the sensors are coming off of the Raptor because they just don't need them now. It's what you need sensors until you've fully characterized the system. Once a system is fully characterized, I mean, you don't need to, if you know what the temperature, of this manifold is under these conditions, because you've seen it 50 times before, you don't need a temperature sensor anymore, right? You know what it is based on the characteristics that determine it. You don't have to measure it at the tail end.
I want to say thanks for the super chat from Steven. Apparently there's a desire for me to go to Australia for some of my Australian subscribers. So let me know if you think I should go to Australia, and if you think so, where should I go? Because I've never been. Oh my gosh.
I want to go to Australia. That seems like that would be a lot of fun.
Never been?
No, that seems it's on the bucket list. I just time zones kill me. So I can't go any place that's 8 time zones unless I'm going to go for at least a few weeks. So it becomes a big hole.
Thaddeus makes a good point, saying, I think there is no utility in keeping good engineers tied up on a dead-end project. They can't be put in use elsewhere, and I'm not of the opinion that they have no alternative uses.
So I think that's a fine sentiment, and I think from an economic utility standpoint, that's probably the right way to think about it. I don't think Congress is all into economic utility, right? So they probably think about this in a slightly different way. And if you do want to maintain a talent of a pool of people who have expertise building rockets, and you're not planning on building any real rockets for 10 years, it's a bit of a dilemma. If those people stop working on rockets and you dissolve those the entities that are doing that, and you sell off the machine tools and whatnot, and then you want to start up again in 10 years, there's an argument to be made that it will cost you more to get going again if you put it down than if you kind of mothball the program and you slow walk these people on some other project. Like, I don't know explicitly that was Congress's intention when they did this stuff. Like, I would have liked to see them do more stuff that produced, I don't know, more meaningful output than just maintaining the work base. I'm just saying there's some utility in keeping the talent base out there.
Right.
And it's worth considering. It's you put it on the table along with all the other things that you think about when you're trying to decide how to spend money.
Well, here's an interesting question for you. Would James be considered a polymath? Would you consider yourself a polymath?
I don't know. That's an interesting question. Go
ahead. Oh, no. Okay. Still thinking about that one. I do think that it's interesting. I didn't know this about you, and I actually learned the word autodidactic, right? So you're self-taught, and that probably surprises a lot of people. So I was kind of asking you before we went live, maybe just some general advice on how people can become better learners.
When we were talking about this a minute ago, I was saying that I really liked Andre Karpathy's response to that general topic on how when Lex Fridman asked him for, when people want to get into ML, what should they do? And Karpathy had said that when people ask him that question, his tendency is not to say, well, you should read this book, you should take this course, you should try to work on that, you should learn this particular skill. People do tend, especially when they're biting off something big, some big new project, they can get really caught up in what's the right thing I should do today, tomorrow, and so on. And Andre basically said, just plan to put the time in and work on what's interesting and work on what moves you a little bit toward that goal, but expect that you're going to put a lot of time into it. And I think if you're trying to learn complicated things, if you're trying to learn something which is going to take 1,000 hours to learn, in a lot of ways, it doesn't matter where you start. You have to start somewhere. It's going to be this big, blob that figure out what's going to keep you motivated so that you can keep doing. When I started doing Japanese, I read all of these. I read a bunch of books about learning Japanese before I decided I was going to teach myself Japanese. And when I actually started doing it, I discovered that most of the things that you can do most of the curricula that are out there were incredibly boring. They weren't really any fun, and it's hard to keep your motivation going. So I switched tacks to, and this is my general approach, is like find the thing that you're excited about doing that's in the right general direction. So that like when you get up in the morning, you're like, oh yeah, I want to go study. And that was my approach. And
how'd you switch it?
I focused on, as you work on stuff, you find that there's some stuff that you enjoy and there's stuff that you don't enjoy. And so you, do more of the stuff that you enjoy. And interestingly, it will tend to backfill to the other stuff. Like the stuff you don't enjoy gets easier as you do the stuff that you enjoy. I mean, you can't be a total slacker and but you can try to find ways to make things fun too. That's another. So I used to be there's another weird thing about me. I'm an ACSM certified fitness instructor. And one of the things when you're going through the course, this is actually one of the few things I actually went to college to learn to do. It was like, I've got a degree in being like a personal trainer. And so in the psychology of exercise, like one of the big challenges when you're trying to, get people on a fitness program that works for them or help them achieve some physical goal that they want to get to, a big part of it is motivation, because most people hate to exercise, right? They really hate it. Like it's not fun. So a thing that you can do that makes the whole goal so much more achievable is figure out like what for you is the thing that makes you enjoy it, that helps you enjoy it, that makes it tolerable at least. Once you crack that nut, then you can put in the time that you need to put in to actually learn the thing. So in the course of learning Japanese, I memorized 40,000 flashcards, and it sounds really boring. Like what could be more boring than memorizing flashcards? But I figured out a formula that was entertaining for me. You find the right flashcard deck, find the right material that you want to work on, figure out how to turn it into a game, gamify it so that you're excited about it, and then put in the time, right? And you get through the material.
Do you mind giving us a little Japanese?
どうして人は僕の日本語を聞くときには特に、なんか意味あるものじゃない。なんか練習する相手が少ないから僕の喋り方は特に綺麗じゃないかもしれない。僕は学ぶときには大体その本を読むとか映画を見るとかそういうことはほとんど。
Oh my gosh, if someone like just tuned in, they'd be like, what's going on? Am I in the right live stream?
I picked up the Nihongo and I picked up the Eigo. So there's like, you said something about Japanese and English, but
I don't get a lot of, I don't know anybody who speaks Japanese, right? So that's a very sort of strange situation to be in for someone who's learning Japanese. So, I watch a lot of movies, I read a lot of books. I have a tutor that, who, I pay to listen to my terrible Japanese, right? And so, for a few hours every week for several years now, I've had a person that I can, and practice is a really important component of being able to develop this stuff. That I started Japanese because I was trying to understand how learning worked in human beings. And I needed a really big project that would take a really long time so that I could observe the process and take notes and whatnot. I started on this before deep learning broke out in 2012, there were a lot of people who hadn't given up on the idea, but didn't know how to go about doing something that was kind of like neural networks, because that seemed like the most promising thing in the space of sort of learning systems where you're relying on their emergent properties to acquire the capabilities that you're trying to imbue the system with. And I was working with people who were trying to build learning systems, and we just weren't making much progress. We were just pounding our head against the wall all the time. And at some point I decided we didn't know what a learning system should look like when it was making progress. Like you'd have all these knobs that you were turning in your system or things that you would design and then you'd run it through all the data and whatnot. And I realized we would frequently be looking at this data saying, is this better than it was last week? You can't really tell. So I felt like it was necessary to develop intuition. Like, so, how do you know if it's getting better? And I had this idea that maybe if you spent a lot of time watching something learn, you would develop intuition about like, when it is learning and when it's not learning. And so learning Japanese was my way of watching myself do that and trying to develop that intuition. And while I was doing it, we had the deep learning revolution and it was all just like moot at that point.
Oh.
But it was a great experience. I learned a lot about learning and I feel like I do have good and useful intuition on that space. But it turned out that all of the, the breakthrough that I was looking for, somebody else found and then it was off to the races, right? And here we are.
Here we are.
Yeah, I think, Ellie, just in the vein of learning, because I had someone send me a tweet a few weeks ago. It's David Elliott. And it was like, Scott, I'd love to hear some free advice for people in industry from you. Example, I'm a machine tool repairman working in aerospace, hyper excited for Optimus and future of robotics taking over my work. Could you make a video about that? And I've talked to John about that. And we're going to get around to it. And I've actually been talking to some other people in the industry, what they think about it. And something was kind of along that line. Here's what one of my friends said. The first question was like, are you a problem solver? Does solving problems excite you? That's the first question you should ask if you want to go into a field like this. Do you want to go deep into unknown problems? Or do you have a comfort zone you prefer to stay in? So you're on the floor, there's a problem. Are you just going to go in deep to figure it out, or just say, I don't want to have anything to do with it? And then as far as robotics, stick programming is very easy to learn. That's where you actually just take the robot out there and with the joystick moving around, learning to do it. And this is an observation that he made, is that shop floor mechanics are better than controls guys when it comes to the robot programming because they have a better feel for precision. There's no need to learn inverse kinematics or complex programming. Robot programming is very visual because you see the robot move from here to there to there, there. Programs are really a task list, a series of steps or a recipe. They are not code, okay? The problem is we call it code and everyone gets scared about it. The reality is when you do the robot programming on the floor, you can sort of see what's going on and really anyone can do it. And the best thing is like Andre Karpathy was saying is just try to get something, just get into it. And his advice is, stay late one day a week in your company if they have a robot around there and get some stick time with the robot. Even if you're on a program, or go over to the guy who's doing it and say, hey, just show me how to do it. Can I hang around after, watch you, and just get a little bit, show interest and aptitude. And then eventually someone in the company will lead you, hey, why don't you take the robot programming course from company X over here, or we'll send you to the community college or something like that. So that was kind of his advice. James, since you're here, what would be your advice or something like that? If someone wanted to actually kind of get in the field a couple of years from now, when Optimus is finally out there and we're going to need people who are going to be servicing Optimus, programming Optimus, putting in what should they do now to make sure that when that day comes, they're ready?
So they can become Susan Calvin, the robot psychologist.
Okay.
That's Isaac Asimov, robot stories reference. There isn't going to be a thing for robots, just like there isn't a thing for cars. If you work on cars, you work on any complicated system, there's all kinds of jobs. They take all kinds of people. And so the first question is like, what kind of job do you want to do? What kind of job do you think that you're well suited to? Working with engineers over the years, I find there are some engineers who want a very predictable job where they have mastered this domain. They want certainty in the tasks that they're going to do, right? And there are other people who are completely the opposite. They get bored really easily and they constantly want to be doing something new and different from last week. And so the approach that those two people would take would be really different. Like they're going to want different jobs, the kinds of jobs that, the things that they're going to be good at are different. And there are roles for both of those people. that there are some things where you want somebody to get really good and be really consistent, and you want somebody who enjoys being good and consistent, and they're going to keep doing that because your process requires it. And there are other things where we got no idea how to do this. It might totally go down in flames, and we need somebody who's happy to be the Lone Ranger, who's going to, just go throw themselves at it, maybe in frustration, patting their head against it for a long time until they make progress. And that's a completely different person. So I think you need to kind of figure that out about yourself first.
Yeah.
The other thing, like the robots, this is going to be an arc, and it's super early days. If you got involved in the airplane business in 1904 or 1910 or 1925, like those would all be completely different worlds with completely different things. And there isn't really anything that you can get into which is going to make you relevant in all of those eras, right? It's going to constantly change because it evolves really rapidly. So a really important sort of skill and mindset to have is this sort of, perpetual student, constant learning kind of mindset, where you accept the fact that things are going to keep changing and you're going to have to adapt, and you keep your eyes open, you keep trying to learn, and you gravitate towards the stuff that you like doing.
Yeah. And can I just mention that sounds exactly what my friend said about that. The different levels, you get those guys that master it and they just want the predictability, and you need them. If they're there, they're reliable. And the others that are the problem solvers that are willing to go in a little bit deep on that is exactly the same. So basically what James just said there is actually confirmed by other people in industry. He's just not making it up. It is something that a lot of people have observed and really feel that that's the important thing. And it comes down to determining, what are you like? Are you a problem solver? And if you are, then you probably want to go into engineering. If not, if you want that nice, predictable 9-to-5 job, well,
there are both kinds.
Yeah.
I was working at a company. We were doing these high performance analog integrated circuits. They were a really key part of our business. And we had a small IC team. The guys were super talented, and the stuff they did was really critical to our business. When we tried to hire IC engineers, it was like pulling teeth to find people who wanted to come work here. And we'd interview people, and then they'd look like they'd be a pretty good fit, and then we'd lose them to one of these really big, completely generic companies that had 10,000 other people. Well, that's an exaggeration. They might have 100 other people doing exactly the job. So we would lose engineers away from what I thought was a really exciting, really impactful, sort of position that they could take, where they'd have a lot of autonomy and they'd be working with a really smart group, and they'd go work at a company that had 100 other people doing exactly their job, and they'd sit in a cubicle next to the other people and do that. And I couldn't understand why people would turn down what I thought was just a tremendous engineering sort of opportunity. And the RVP at the time was a guy he'd been a VP of engineering at Intel, and he'd hired tons of IC engineers. And he said, my experience with IC engineers is they mostly want a pretty predictable job. They want to be good at something. They want to do it. And you need those people too, right? There's a point where you need that. But the people who are willing to take the job, the unpredictable job, they seem to be in the minority. So, and I don't want to cast shade on people who want to, have a 9-to-5 job and go home and play with their kids and have work-life balance. That's a thing. People should have it if that's what they want. I like being passionate about my job and losing sleep over it and just completely pouring myself into it for 3 months, but that's not everybody's priority. I don't have kids, right? So that's probably a big difference there.
I'm curious, James, because I saw you at AI Day, but I didn't say hi to you because there was just so much going on. So I do want to ask the question. I know it's kind of outdated at this point, but since you've had more time to think about AI Day, what is, a big takeaway or just something that you're really excited about after seeing all that in person?
I think my biggest takeaway is it's a real thing. We externally, Tesla said they're doing all this stuff, but we don't see the people, we don't see the intermediate stages of the products. I don't know if they're secretive, but not a lot leaks out. So, so at some point, when you're following it from the outside, you know there must be all this stuff going on inside, like building a robot. They said, oh, we're going to build a robot. Well, this isn't like 3 guys and a Dremel tool, right? I mean, this is a big effort. It's going to involve a lot of people. It involves a lot of different kinds of expertise. And it's one thing to say that you're going to do it. It's another thing to like put the team together and get all this kind of stuff. So the takeaway for me going to AI Day, coming away from it, is like, it's real, because you get to see all the concrete pieces. There's a reason why, the presentation seemed like it was all over the map, because it's a big effort. It's got lots of engineering. And if they want to spend 15 minutes on all these different things, because they want to attract people who are interested in that particular problem, you can't spend a lot of, you have so much ground to cover. And so like if you're trying to digest it, that's a very frustrating place to be, like, because you got 15 minutes of really deep stuff and then 15 minutes of really deep stuff on some other topic and so on. Yeah, it's just overwhelming. But the flip side is, if what you are looking for is evidence that they're really serious about this, that they're going to execute, that they're thinking about the right stuff, they're pouring the resources into where, and that they've got the chops to attract the talent that's able to do this. Well, that's exactly the presentation that you want to see. So I found it overwhelming, because I got there and I'm like, I got 2 hours. I have to talk to everybody, right? Yeah. And I got I made no progress, because there were so many people and so many fun, things that I wanted to get to. But then the flip side is, like, after it settled down and I had I had some time to digest, so I'm like, well, yeah, sure. Like if you went to NASA, right, and you had 1 day and you wanted to, you wanted to talk to enough people at NASA to know that they really knew what they were doing. Like, it's a fool's errand, right? You can't possibly do it, because it's a big effort.
Yeah.
And so, if you're able to completely get your head around what they're doing in 3 hours, they're probably going to fail, right? Because it can't possibly be that simple. So that's my takeaway.
Mm-hmm. Yeah. Speaking of leaks,
yes.
Did you see the Tesla videos that they released over the weekend? Tesla released 2 videos.
Do you know how to screen share on your end, or do I have to do it for you?
No. Let's see.
You add it.
There's a screen share at the bottom.
Yeah, screen share at the bottom, and the thing is, okay,
it's next.
There we go. Finally, I got it. It was being blocked by my.
Let me know when you have it up.
There we go. All right, so we should be able to go do that screen share over here, and we're going to screen share, and we're going to screen share this one right here. So this is something that came out. Did you see this one?
It looks.
And
familiar.
is it showing? Yeah, and if it's going to show right now, come on, let's show. And of course, now it's just giving a completely black screen. Oh, here we go.
Cool.
So I was wondering what your thoughts were on this, if you had seen it.
So can you give people context for those who haven't seen it?
Yes, so I did see this. So I'm working from memory here, but they were talking about the actuator design
yes.
project, right?
Yes.
Which, Scott, you and I have talked about this. This, in my opinion, but even before I knew they were doing, they announced doing a humanoid robot. I was talking to Dave about how I thought actuators were like a super important thing, and that, one of the reasons why Tesla is the right company to be doing a humanoid robot is because the actuators are really hard. And the companies that are out there that have the right corporate culture to do this, and they also have the right expertise lined up to be able to solve the actuator problem in a way that really gets you to, it gets you on a path to a long-term track to the kind of performance that you need to get to if you're going to make tens of thousands of these, and they're going to be if you're going to make 1 million of these, and they're going to be $10,000, and they're going to have everything you need. You have to take a different approach than if you're going to build one-off multi-million-dollar machines. Just nailing the actuator problem is a really important component of this. And it's what I think is one of Tesla's key advantages in doing, and it's the reason why I wanted to see Tesla doing this. Mm-hmm. Because I felt like they could do it, and it is really important. So in this video, they're trying to recruit people to work on the actuator team, and they're giving us little glimpses of what's going into some of the actuators that they're building.
Yeah, they showed anything that jumped out. Yeah, that was way back there, and that's a bit interesting. Probably because it's the assembly, it doesn't seem to be behaving the way I expect. Because I was looking at this planetary roller, and do you see that little drop right there? I'm not sure if that's an imperfection or if that's actually a little bit of oil that's on there, but it rotates a lot faster than the planetary. I was like, how can that be possible?
Yeah.
And I realized it's probably because someone on the other end is twisting it and putting it in. It's not the thing actually running. Yeah.
Yeah, I think they're installing the planetary roller into the sleeve that it goes into there. That's not part of the ultimate mechanism.
Yes, and they have a video of it that shows how the planetary rollers go. Now, I was intrigued by something here that John and I looked at a little bit closer. I just wonder what your thoughts are going to be. It has to do with this foot right here. So you see what he's doing right there?
He's flexing the ankle.
He's flexing the ankle, and notice how the servo is reacting to that. And then look at this wire that's coming on down there. Whoops, let me bring that back. You know, why is that wire there? There is no servo in there. So this wire is coming down here because they obviously have some
load
sensor
in the foot.
They got a load sensor in the foot. And what I'm wondering is if they actually have a little bit of rotation about here, because it's really a 2 degree of freedom ankle. They never really had this kind of yawing that you would have in there. However, that might get it in there, but it might be kind of a compliant joint to just move a little bit.
It might not be an activated joint, right? It might be, you know, they're figuring out how much foot splay do we want on the robot. And so they have an adjustment where you can tweak it.
Yeah, so either they're adjusting it, or I'm wondering if they actually have some sort of a torsion spring in there that allows it to move just a little bit.
Yeah, that would make sense. Make it compliant.
Because I'm thinking when you're doing the stride and your foot plant is going down, there's going to naturally be a little bit of lateral movement. And you might be able to take that out to keep the foot from just kind of sliding off to the side. And that also takes maybe a little bit of a load off the knee, because if you really plant that foot and don't have that degree of freedom, you might be putting some stresses throughout your structure that over time could become an issue. Another thing that I was wondering is when I looked at this drive unit, when you actually go into the animation they did of that, it occurred to me that the way that roller is going, that this shaft actually wants to spin along with it. And it's only if you kind of prevent it from spinning that it won't spin, right?
Yeah,
how are they preventing that from
there's
spinning?
There's going to be a longitudinal fitting in the back of that sleeve that prevents it from rotating, so that, because otherwise
that's what I was wondering.
Work, right?
Yeah. So well, I'm wondering,
it could be restrained externally also, but I don't think it is. It looks like they're trying to make the design of these actuators, by and large, they're designing them to be structural components of the body. So you don't want, I mean, it's ideally you don't require the external structure of the body to provide constraints that the motors require for proper operation. I mean, in a really optimized robot, you might do that, but I think at this point they're probably, putting all the constraints into the actuator itself.
That's what I was wondering. I couldn't quite see it in the design, and so I was thinking, well, wait a minute, the only way they're going to be able to get that reaction is right down here, but that means that joint is kind of taking that, and I'm not sure that's a good thing.
Well, you can tell it's not, because because that's one of those polymer ball in socket things, and it would be rotating.
If it would for sure. It would for sure, and it would be bumping up against something else in there, which is what you don't want. Yeah. So it would be up at the limit.
They have to have that ball joint because they have the two different gastrocnemius calf things, because they want that second degree of freedom at the ankle.
And they do it at the wrist as well. So that was a clever thing. So I think they might just have a little bit of movement in there. Certainly they're measuring it, and they seem to have some sort of force torque sensor that I'm assuming might actually be part of the control system. And when they go down there, they want to see how that foot's reacting to the surface for balance.
Well, talk about Sethia.
Because it seems that, clearly as he's doing it, the system is reacting, and that might just be testing it out. It reminds me of how a cobot would work.
Sethia says a true test would be teaching it to walk on ice.
Yeah, it's not going to walk on ice. And the other thing that everyone asked about is, like, why is the foot flat? And are they going to end up having toes or something like that on there? And I'm kind of the mind that they're not going to have active toes, but they will probably have something that flexes.
Sure, a compliant member.
Yeah, the reason is that right now, if you look at the surface and if you look at the foot is like this. And when you look at it at its best walking stride right now, the foot comes down like this, and it pretty much stays down there. And at the last second, it'll do something like this. And the second you go like that, you go from having a huge surface area to just this edge. Yeah. That's all you have. and that's just going to slip. That's not really what you want. You like to have
Tesla
a little bit more
said that
contact.
they had moved on to a toe off gate, right? So if if you're walking and you have to plant your foot, your gait is, like you're waddling like a chicken or something. If you want to have a natural stride, you have to step off the toe.
Yeah, they're coming off, and so they're holding it down as long as they can, and then they just kind of go like that up off the toe. But you can only do it so much.
Having it to a compliance member with 1 degree of freedom, so to provide a certain amount of balance, but still allow the robot to roll forward. Yeah, that makes sense.
They might get a shape like this just to make sure you get something on there just before the toe off. Because if you look at their stride, you'll notice they don't do the toe off until the other foot is actually down. So the front foot and the back foot are like this. The front foot hits, and as soon as the front foot hands, whoa, now we can do the toe off, because they know if you're just doing that and that other front foot is still in the air, you don't have a whole lot of support.
But the gates will change over time as they improve the controls, and they will eventually go to using a neural network to do the control gate for this kind of stuff, because this is very different from the rocket, and this is the kind of place where a neural network is going to pay dividends, and it's worth
you can run it again and again and again.
Yeah. Well, the other thing is it's really that's another conversation. We're getting pretty far away from the space topic.
Yeah, I know.
I'll get you back. Yeah.
Just really quick, Douma says, James, please produce a glossary for us simple folk to translate some of your references. I do sincerely appreciate that you always make it easier to understand the tech, but it's still a lot to take in. So maybe we'll just take it down a little bit, because I'm certainly not a roboticist. But you had an interesting thought experiment, Scott, that had to do with
here. Has to do with your what t-shirt are you wearing right now?
Oh, it's just a
Ellie.
Well, it's a Tesla sweater.
I'm wearing a Cybertruck t-shirt.
Okay. It's cold. Okay. We came to San Francisco and the heat hasn't been on here for days, and so it was way too cold for me to wear a t-shirt in here. So for the first time ever on the podcast, I'm not wearing a t-shirt.
Yeah. All right.
No, so here's what I have under here. Okay. So I don't know if I can show this. This is the Hyperloop competition t-shirt.
Oh, cool. And they're that down. Breaking news. Okay. They're gonna make it
okay, next time someone ask him about that, because we felt that since you were always wearing like Starlink and Occupy Mars and everything, secretly you were telling your host, I want to talk about space for once.
My Tesla wardrobe. No, it's just it's for years now. If somebody wants, my family, if for Christmas and birthdays, it's like, what do you want? Give me a Tesla t-shirt, give me a SpaceX t-shirt. So I've got a whole closet full of them. It's my whole wardrobe. If you're a t-shirt collector kind of person, you have these layers of strata in your t-shirt drawer, which is like the stuff you're into now, the stuff you were into a couple of years ago, and then the stuff you're into below that. So right now, the upper layers of the upper strata are all Tesla and SpaceX stuff right now.
Yeah. Those rock concerts you went to like 40 years ago, they're still down there. Well,
I have all these rock climbing t-shirts down at the bottom. Those are the first stuff that I bought.
Oh, there you go, Ellie. Oh,
are you a climber as well? I climb.
Oh, you're a rock climber? Yeah, I was a super hardcore rock climber back before it was popular. I stopped doing it 25 years ago, probably.
Climbing today. That's awesome.
Oh, wow. Where do you go?
Here in Portland, just at the local gym. I like leading. Do you do like sport climbing or bouldering?
So when I started, there was no sport climbing. In fact, I built one of the 2 or 3 very first sport climbing walls in Los Angeles back when I started doing it. And like when I built my wall, we had to make our I poured polyester resin and sand into molds that I made out of silicone to make my own holds and stuff. But at the time, if you're building your own wall, you build this tiny little thing, and they're all just for training. But all the really fun climbing that you could do would be on natural rocks outdoors, and you would have to go there. And then toward the tail end, when I was climbing, gyms became a thing. But then I stopped climbing, and I kind of I peaked at some point, and it's hard to stay. Like climbing was like a 40-hour a week job for me toward the end. And it was like, I'm not going to get any better unless like I go live like a hobo. And I knew people who were doing that. You become a rock climbing bum, you get a van, and you just like travel from crag to crag. And I didn't want that lifestyle. So I decided to stop climbing.
Dang. Okay. Well, that's interesting. Fellow climber here, but we were getting into the thought experiment.
Here it is. So let's imagine you have 3 identical Cybertrucks. We put one on Earth, one on Mars, one on the moon. Okay. Which one will have the fastest 0 to 60 or quarter mile, whichever you want? And if you want, everyone, just start putting answers out in the conversations.
What do we assume is the surface that you're
okay,
on?
exactly. I knew that would be the first thing, because we need to make sure we have the same surface, because obviously if we're on Mars or the moon, you're going to have lousy traction. So we'll assume that we've been able to engineer identical surfaces for all 3 planets, or all 3 surfaces. So we don't have to worry about.
And here's a hint: you're traction limited with the Cybertruck.
Yes. Okay, so let's remember that what we have is identical Cybertrucks. You are allowed to adjust the pressure in your tires, but it's the same tires. They're not special tires, but you are able to adjust it for whatever the conditions are. And so, does everyone think it's going to be faster on Earth, the moon, or Mars?
Well, we got a lot of Earth. We got a moon. We got a Mars. Got another Earth. Moon.
Okay, we get the moon.
Mars.
Now the question,
Show your
Mars
work.
For sure.
Why?
Show your work. Why? Okay. So let's remember that the Cybertruck is going to weigh something different on each of these different planets, right? So we have different weight. So you would think, different weight. The moon is what, 1/6 Earth's gravity? Does that mean if we have the same Cybertruck with the same horsepower that we're going to get 6 times the acceleration on the moon? What do you think? 6 times the acceleration? 3 times the acceleration on Mars versus Earth?
James?
So you're asking the audience, right?
Asking the audience. James knows the answer. I mean, he knows the answer. Okay.
Okay.
Now let's one more thing here. It's not only is it the same surface, it's flat. It's absolutely horizontal. There's no uphill. There's no downhill. It is definitely horizontal. So the question is, when it comes to the acceleration of the Cybertruck, just looking at the acceleration, does gravity come into play at all? The Cybertruck's lighter on the moon, right, Ellie? And it's like if you're pushing something, that you get the acceleration. So if it's lighter on the moon, would it be easier to accelerate it on the moon?
I want to hear James answer.
You want me to answer it?
Yeah, go ahead. Yeah.
Okay, so the inertia of the vehicle doesn't change, and you don't get to a speed where air resistance matters in a 0 to 60, right? To first approximation, that's 0. The Cybertruck is so overpowered that it's traction limited. So the only thing that matters is traction. So what affects traction? Well, traction is basically how much friction do you have between the wheels and whatever surface you're on. If you're on the same surface in any environment, then the variable is you have the same rubber, you have the same other component. So the thing that determines how much force you can apply to that surface is the normal weight that you're applying between the two, right? If you do a first approximation for simple models of friction, if I have twice as much weight, I can apply twice as much force before I slip. So on Earth, you're going to have the maximum weight, you're going to have the maximum traction, and you're going to accelerate the fastest, because essentially the Cybertruck's got incredible amounts of torque, and it can only really use it effectively if it has a lot of weight. And so this is an interesting, sort of other experiment that you could do, is put a bunch of weight in the back of your Cybertruck, because it's probably the case that even on Earth, the fastest 0 to 60 you get in a Cybertruck is not going to be with an empty bed, because it's traction limited, right? So you're going to start throwing sand in the back, and at some point the weight of the sand will slow the truck down more than the improvement in traction will help you. But it's probably 500 pounds of sand or something before you get to a point where the weight is, where the inertia, the increased inertia, is hurting you more than the increased weight is helping you.
On Earth, on the moon, it would probably be a lot more to get that.
Yeah.
Now you get way more inertia, a lot more
Cybertrucks on top of it, and you'd still come out.
Right? And of course, if the other thing is that on Earth, you could put a spoiler potentially on the Cybertruck, and that would help give you. That's why cars have those spoilers in the back. They're actually an airplane wing that creates lift that goes down, not up.
Spoiler at 0 to 60 is tough to, because it's you got nothing until 30 miles an hour and then not much.
And you're getting a little bit. So if you were going to, spoilers are not going to work in the moon. They're not going to work on Mars for sure. If you're doing a quarter mile, then maybe, then it might have a little bit of impact to be able to get it. But the key is the traction. So that's why I said the same tires. You can get the pressure on there to make sure that the shape of the tire is pretty much the same. So you get the same tread area down there. And surprise, surprise. The Cybertruck is probably overpowered for the moon and for Mars.
It's probably overpowered for Earth too, frankly.
Yeah.
It's got a lot of power.
more power than you need. Yeah.
So not everyone passed the test, but that's all right.
And we thought that, I thought that would be kind of a fun little exercise to think about. Yeah.
James, do you have any fun little quiz for Scott? Since he put you on the spot.
Yeah, no, you probably should have asked me before I came on so I could come up with something good. I won't be able to come up with that on the spur of the moment.
Well, I think one of the things about the Cybertruck, the performance that will be interesting is you need to regulate the batteries, right? And it's very easy to do on Earth because you have a radiator that you can just dump out to the Earth's atmosphere. So it's going to be interesting. If you are operating the Cybertruck on the moon or on Mars, you're going to have a lot of problems with the thermal management. Because
so I worked this problem trying to figure out if we put Optimus on, I feel like putting humanoid robots on the moon or putting robots on the moon, in one of the early shipments up there to start building your lunar colony or whatever, that's a great idea to do that kind of stuff. So how much do you have to modify? Like if you have an Optimus that works in a factory, what do you have to change to put him on the moon? Some things will probably have to change. Surprisingly little has to change. But one thing that is really key is how do you get rid of waste heat so he doesn't overheat? Because in a vacuum, you can't shed heat to the air around you, that's a primary way that you're able to shed heat, if you're in an atmosphere at low temperatures and blah, 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 blah. So in space, you have to rely on black body radiation for the most part. If you work out the math, it turns out at room temperature, you can shed, 18 watts per square meter into empty space. And that's enough. Like in terms of the waste heat that you have on Optimus that isn't working too hard. So you'd stick fins on him. He might end up looking like a Stegosaurus, with all of the fins on his back to radiate heat or whatnot. And luckily in space, on the moon, they don't weigh anything. So it doesn't really matter. So Optimus might end up looking a little bit different at working in a vacuum, but you probably don't have to change really much at all. The battery's probably already airtight and, it can take 1 atmosphere of pressure, and the motors, they all work in a vacuum. It's the biggest challenge would be lubricants, right? Because you get vacuum welding, which is a real problem when you're operating in a vacuum.
Yeah.
But there are dry lubricants that might be a direct substitute that you could use. I'm sure they're using liquid lubricants in the actuators that they have right now, but they're probably all sealed bearings and stuff like that. So to a first approximation, you could probably put Optimus on the moon, and if he wasn't moving too fast, he'd work okay. And then if you added a black body radiator to him, it'd probably work fine. Right?
But you just have to make sure the lubricant doesn't potentially freeze if it gets too cold. That sometimes is a problem.
Potentially. If you weren't expecting a lot of lifetime, if you were shipping some Optimi up there for an experiment and you just wanted to operate them for a month or something like that, just to, see how it works and do some limited amount of stuff, a straight factory Optimus with minor modifications, it might work just fine.
Yeah.
So John says the biggest problem on the moon, he's talking about the regolith, is that super fine dust. So it's all about actuator wipers.
Yeah, that's a big deal. The moon, it looks like dust to us or talcum or whatnot, but it's actually tiny little shards of glass. So, effectively, because there's no atmosphere to dull the edges on stuff. So every time you get a fracture, they're super, but it is silica mostly, right? And I guess I don't, is there a lot of alumina oxide in regolith? There are some pretty hard minerals that you might have to
I think so. Yeah. I think there is. Yeah. It's pretty nasty. And
John Schlick is probably right. The actuator wipers, they're going to be important. But it should be possible to do a good job with that, I would think.
Have you wanted to go to space, James?
Oh man. It's, if it had the right sort of safety profile, then I would do it. I was a daredevil when I was younger, and I'm not anymore. At some point I decided I don't actually want to die. So I started being more careful about things. But it, like, if it gets to a point where like you can get a weekend and go to the moon and stay in a hotel, I'm going.
What about,
I'm saving up for it right now.
Let's say tomorrow you get a seat on a Blue Origin ride. Yes or no?
Probably not. The Blue Origin stuff doesn't excite me. The whole going up in an elevator and coming down in a parachute, I need it. It's like, for me, it's orbit or bust. And even low Earth orbit, it would be pretty cool, but I don't know if, given the current sort of risk profile, I don't know if I'd be all that interested in going. The other thing is I get I get motion sickness like there's no tomorrow. So like the risk of no, it's like I really next level. So, but like to go to the moon, I would probably be willing to like do what it took to overcome that, because I think that would be, taking a week or 2 weeks and going up there and standing on the moon and looking at Earth from there, like that would be worth taking some risk for. I would really be into that.
When do we think that'll be an option?
Yeah, I think
it could happen pretty quick after Starship, right?
Yeah.
I mean, when I say pretty quick, I mean I don't mean like 2 years, but I fully expect to see that in my lifetime, right? It's and I'm an old man, so it's not that long. I think in decades it could be doing. I think that there's a good chance that the Dear Moon project, like they'll do that inside 10 years or whatever. Probably a lot sooner than that. I mean, Starship's not an easy thing, just like FSD was. Elon's super optimistic on day one when he does that kind of stuff, and we've heard optimistic appraisals of how quickly Starship was going to come together. But in a lot of ways, it's coming down the home stretch. We're going to have our Falcon 1 moment with Starship pretty soon, and then the Falcon 9 moment, with Starship. We'll get that in, a couple of years maybe. And then, it'll take them 3, 4, 5 years to make it really solid and regular and repeatable, and then we go to the moon.
Yeah. Now the question is, what's the transportation system going to look like on the moon? Because the regolith is a problem, and they know when they come down to land, they're going to be blasting it up basically into lunar orbit. And before you know it, the moon will have an atmosphere. It will be called regolith if you just keep on,
it falls right back
too much
down,
of it up.
Right? There's nothing. It's ballistic.
But it seems like it stays up there a lot longer than people thought. That was like, I think some of the concerns that they were doing, that they might blast it up to such an area that it could take a long time before it comes down.
You could go orbital.
So there's some concern.
I mean, you could probably have put regolith in orbit from rocket exhaust landing, and so it might stay up for a little while. But
so that's why they want to have a pad. So when you're coming down on a concrete pad, you don't have to worry about that.
I mean, you'll want to do roads.
Yes,
probably.
You're going to want to do roads also,
and it'll be easy to do roads too.
Yeah. And if you remember in, what was it, Space 1999, they had those Eagles. I'm trying to remember how they work. Was the propulsion system just like compressed gas or something like that they used to go around? And that may not be such a great idea, because you're just going to be kicking up dust, kicking up dust. And you get enough of those things going around. I mean, really, you're going to just have an atmosphere on the moon, which is not going to be what you want to have.
So John's raising another good point. So one way that I'm probably an outlier in the space stuff is I'm actually pretty concerned about gravity as a necessary component for normal human function, and especially development. Like if you want to have kids someplace else, if you have kids on Mars, you raise them in a third of a G. If they make it to 10, 12 years old, they're never coming to Earth. Like they're not going to have a body structure that's capable of enduring it. So that's a thing. Maybe you don't ever want to go back to Earth. But another, important question is it even possible for, a large mammal to develop normally? Like it's because, it's our evolution has been completely constrained inside a 1G well. And we may find that there are really difficult to overcome side effects of trying to, have a large mammal develop to maturity in low gravity. And getting a 1G environment on the surface of Mars is going to be really, really, like you could in principle build a city that spins or something like that and tilt it at an angle, but that'll be harder than building a space habitat and spinning it and generating 1G, right? Like at that point, it is so easy to get a G on a space habitat. Like if you can sign up for 1 billion tons of, or millions of tons, 10 million tons, if you can sign up for 10 million ton scale construction, you can build habitats that have gravity, for all intents and purposes. And so that's one way of solving the problem. And then the other thing is radiation, right? If you
say someone else came in, we need to be more concerned about that than gravity. What do you think?
Yeah, so short-term radiation is a much bigger risk than gravity is, for sure. Long-term, gravity is also a very serious problem that you have to overcome. Now, it's because we haven't tried, nobody's tried to raise cattle on the moon, or we haven't tried we haven't sent primates to Mars to try to raise them and see if their development will be normal. And at some point you'll have to do that just to figure out if it's possible before humans try having kids in that environment. But I think it's a real serious problem. And the thing about gravity is there are lots of ways to fix the radiation problem, right? Like mass will fix your problem. You can just build bulkier. But if you have a gravity problem on Mars, man, that's a really hard problem to fix. So if it's really a problem, like if you really need to have 1G, you can't inhabit Mars. It's just not going to work out. It's going to be way cheaper to build habitats in 0G than it will be to build on Mars. And that would be unfortunate. Long-term, biotech probably solves the problems, but solving the gravity problem, it might be many times more difficult than solving cancer. We've been pounding our heads against cancer for a really long time.
Is that something you truly worry about? I mean, I know we're all so excited about Starship, but has that kind of been in the back of your mind of is this whole plan gonna be ruined once we finally get there?
I actually, I think, for a PR standpoint, from keeping people excited and eyes on the prize and whatnot, focusing on Mars is not a bad idea. The thing is, if you can do Mars, you get the moon for free, right? And if the moon ends up being the thing, so for me, if Mars is a plan and the other plan is habitats, and if you want to build habitats, you use the moon because it's the universe is a gift to us. Humans, we got a planet, it's got air, it's got all these great things. And when we get to space, we have all this construction material, more than we could ever use. And it's at exactly the right distance from our planet. It's right there. It's got no atmosphere. It's 1/6 of the G. Hauling construction material off the surface of the moon to build stuff in space, it's a dream. It's the perfect resource. And it would be crazy for us not to use that. So my expectation is at some point we build a linear accelerator so that we can you can do your dirty, materials extraction and refinement on the surface of the moon. And then you put it in a linear accelerator and you fire it off into L1, right? And then, or L2 or L4, L5, fire it off to some Lagrange point and build your space habitats there. It's super cheap. It's super energy efficient. It's clean, and you got all the mass that you could ever want. You could build, trillions of human beings worth of habitable capacity. It's just a matter of time. And, if you have Optimi to do the construction work for you and they can, build more copies of themselves, we can use it. We can von Neumann probe our own solar system until we've got more space than we can handle.
It's so weird of imagining looking at the moon and having it not be blank,
Yeah. I'm really excited about the day that we look up in the sky and we see, city lights shining on the moon back at us.
I've never thought about that until now.
Yeah.
Wow.
That's going to be something else.
I think, we will see that, and it won't be that. And my guess is we'll probably see that before we have colonies on Mars, just because Mars is a lot harder. Like I said, if you aim for Mars, it's just you get Starlink for free on your way to Mars, because why not? It's, it's a super useful thing that's pretty straightforward to do. And it's not easy, but the challenge to doing Starlink is mass capacity to orbit. And once you got mass capacity to orbit, even at the Falcon stage that we're at right now, even before Starship shows up, it's a thing you do. It's super valuable to people on Earth, and that helps you generate the cash that you need to keep moving forward. One of the challenges with both Mars and the moon is coming up with comparable, economic rationales for doing it. Like if you can come up with a good economic rationale, then making the project move forward, funding it becomes a lot easier. But Starlink is the low-hanging fruit, as it were, on this. After there's planetary imaging too, right? Planetary observation and whatnot. Like that'll that's another one right up there. It's a low-hanging fruit along with communication. But after that, then you have to start drawing on the desire of people to expand. And I don't have a good enough sense of human, like what people in general want to know how many people are really excited about leaving, because Earth is pretty cool. Earth is a great place.
I think there's plenty of people that'll leave, like that want to leave yesterday. So maybe not all of us, but I don't know. And talking, I feel like a lot of the like SpaceX people that I know, actually, at least the ones working in Boca Chica, are like, yeah, I want to be on the first trip. That
would be great. Like I like to think that that sort of spirit is still it. I think about what life was like. My dad grew up working a farm as a kid, right? And so like one of my touchstones for how much life has changed as modernity has spread is listening to my dad's stories about growing up, working on a farm in Iowa in the wintertime, right? In the like 1950s. And then I think about his dad, like the stories his dad was a farmer too, right? Or his dad's dad, right? And like our family memory goes back that far. And these people's lives are radically different. Those people, if you asked them to go to the moon or something, it wouldn't have seemed like a big challenge to them. But today, life is pretty, at least for people in the first world, life is pretty comfortable. It's not super risky. And so I find myself wondering how, if the fire is there to still do this stuff. I hope it is.
Subcreation, speaking of economic purposes, I think asteroid mining is the real prize. Is that something you've thought about a lot?
It's the economics of asteroid mining are a little bit complicated. At some point it gets really economical and it makes a lot of sense. The thing is, there's this window of time where like your space transport capabilities and your time horizons have to get pretty long before the energetics of basically mining the moon, the energetics are a lot better than asteroids in the short run, because it's a lot easier to get to haul your industrial capacity to the moon and develop it and do your refinement there. So the only thing you're shipping back is the refined stuff. If you go out to the asteroid belt and you ship raw asteroids back, then it's a little more complicated. I mean, there are things like Psyche, right, which is probably mostly metal, and that has a lot of value by itself. But I'm not sure that the basic physics of like going out to the asteroid belt, even if you have a solid iron asteroid and pulling off chunks of it and bringing it all the way back, is actually better than like going to the moon and setting up an iron smelter, because then you can use a linear accelerator to toss it into almost any place in the solar system, right?
Mm-hmm. Yeah, that becomes the biggest problem with rocketry. It's always the propellant. It's not an energy problem, it's a reaction mass problem. And you always have to carry your reaction mass around with you wherever you are, and whatever future reaction mass you need for everything. And that's the tyranny of the rocket equation. But if you can find some way to just push against something else, and that's exactly what a linear accelerator does, and you don't have an atmosphere to worry about.
Yeah, you could end up with a thin atmosphere on the moon if you engage in enough activity that generates gas, right, as a byproduct. Yeah,
but probably not enough to slow down the linear accelerator. So
no,
you would be able to do it, but
just enough to be annoying, not enough to be useful.
It just doesn't work in the Earth. I mean, if you could get up to orbital velocity, which maybe you could with a linear accelerator on Earth, but as soon as it comes out, it's going to just burn right up. That's the problem.
It's a total, from an engineering standpoint, it's totally doable. Like I actually sat down and worked out the numbers on doing this kind of stuff. I was curious about whether you could toss stuff straight to the Lagrange points, because one of the things, like
yeah.
if you have if you fire something off the lunar surface in a non-hyperbolic orbit, you have to do a correction at some point, because otherwise it's going to come right back down and hit the ground right really close to where you fired it off from. So so if you don't want to, I mean, if you want just dumb ore pods, you just you make slugs of metal or whatever that you're firing into orbit, either something has to catch them on their first orbit before they come back down, or you have to put a motor on every single one, and that adds complexity and whatnot. Like, how do you get the motors back, because you want to reuse them and that kind of stuff. So an interesting possibility is, like, what does an orbit look like where you fire it off the lunar surface with a linear accelerator and it comes to a stop at a Lagrange point? Like, that would be pretty cool.
That's
I think the orbital
tricky.
mechanics doesn't actually quite work that way, unfortunately.
Yeah, that's tricky. That's the problem with space, is that there are no brakes in space. You need a rocket motor to be able to turn you around. So yeah, you can get up there easy, but then how do we put on the brakes when we get to the Lagrange point to say stop?
Well, I mean, if you use robot tugs, but then once again, you need reaction mass, and you have to get it into space. Yeah, and the easy reaction mass is, it like oxygen and methane, right? Those are actually, unfortunately, not super easy things to get on the surface of the moon.
Yeah, right. And I mean, you can imagine it. Oh, we'll just put a big catcher's mitt up there in the Lagrange point, or we'll just wait for it to come, and you catch it. You think, and then next thing you know, it's like, whoa! It's like you get knocked out of the Lagrange point. There's no way to hold it there.
Unforgiving.
Yeah, absolutely. It's going to have to be a pretty massive catcher's mitt to be able to stop it. Yeah,
for some reason,
and even then,
for some reason, someone wants to know how old you are, James. But I want to know: were you interested in Tesla or SpaceX first?
Man, I don't remember. That's it. Like, I've been aware of both of them for since day one, since they started doing their thing, and they're interesting. Well, who wouldn't be interested? Yeah, I don't really know. I mean, I got when Tesla started doing autopilot. As I said, I had worked at an EV company, and I know. The received wisdom in the EV industry back in those days was like, EVs are doomed. The world hates EVs. Like, it's just so hard to get it going that, like, I was cheering for Tesla on day one when they started doing their thing, but I was very skeptical that they were going to be successful. So if into them means being a fan and being really excited and looking forward to their future, it wasn't until like the Model S came out or whatnot that I started thinking, yeah, these guys, they really have a shot. They could do it. And then when they did autopilot, I'm like, that's it. I'm on. Right. In fact, I went and ordered one right as soon as I found out about this, because I'm like, this is going to be the coolest thing ever. This is this is going to have so much impact on the world. And they're doing it. I mean, I've said a ton of times, they're doing it the way that I think it should be done. And that's what made me excited about it.
And then what about SpaceX? What spurred your interest in space?
One of the youngest pictures I have of me is standing next to a J2 rocket engine at Johnson Space Center back when they used to have a rocket garden there. It's not there anymore. But it's like I was a kid who built the Saturn V model for, your second grade science fair or whatever the thing is.
Which one? The Revell one?
I built mine out of toothpicks. We were working class, man. We didn't.
Okay. Wow.
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 That.
Yeah. So, they're both super. I mean, who's not? You can't be a dork and not be excited about these things, right? They're great.
Yeah.
This is hope for the future. This is like, if so I'm 57 to the person who asked, and I discovered science fiction novels when I was in, I don't know, 6th grade or something like that. And I almost, my sister, who's 5 years older than me, is a science fiction fan. She discovered it before I did. Our family is all readers. Like, I didn't even know that this stuff existed. Like, there weren't really bookstores where I grew up. And so she sent me, we were visiting her one time, and I saw a science fiction novel, Robert Heinlein science fiction novel. And I was super into this. So for Christmas that year, she sent me a cardboard box full of paperback science fiction novels. Right. And so this is one of my stories being a kid. I didn't stop reading. Like, I read 24 hours a day those books. And like after I'd been reading for days on end, my mom would cut our hair before the school year, before we, at the end of vacation. So after Christmas, she'd have us strip down to our underwear and stand in the bathroom, and she'd cut our hair so it would be really easy to vacuum up or something like that. And I just like fell over because I'd been reading for like 5 days.
Oh my God.
So yeah, like, if you, rocket ships and robots and all that kind of stuff. Like I was into that from day one. That was what I lived for. And it was, going through the, 80s and 90s were kind of, cyberpunk is cool, and the development of computers and all that kind of stuff, and cell phones, smartphones coming along, like that's all really great. But like a lot of people, like like robots and spaceships they're just part and parcel of my my core expectations for a cool future.
Right.
Well, sci-fi was basically always about robots and AI in space.
Yeah, I don't know. There are lots of really interesting themes. It's a spinoff from, horror and cowboy novels and detective novels and that kind of stuff. There are all kinds of themes that continue in them. But go back and read the stuff from the 20s and 30s. Like there's amazing science fiction that was written back turn of the century, going back to the late 1800s. There's amazing stuff.
We have another Mars-related question. Tin Man wants to know, how far would one need to live underground on Mars in order to equal Earth's gravity so we could maintain most of our bone density?
Gravity goes down the deeper you go. It doesn't go up. So you don't win by going down, unfortunately. In fact, there's no way to get to Earth the only way to simulate Earth gravity in the environment of Mars would be to build a spinning structure and use centripetal force unfortunately.
Yeah, it's the only way we know.
That's why it's a problem, because there's no way to simulate it within, like, our current understanding of physics has no way to do it.
Yikes. Also, you guys make sure to leave more questions for James while we have him, but thank you for everyone for watching, including Jessica Kirsch, who lives down there in Boca Chica. How's it going?
Hey.
Let's see.
Homie, yeah.
Sethia wants to know, what about Earth pressure?
Earth pressure? Air pressure?
Atmospheric pressure. Well, bring up Venus. I mean, that's an interesting example.
Yeah, Venus.
Yeah, seriously.
I'm sorry, that was tough.
The cloud cities. No, the cloud cities.
Yeah, 900 degrees centigrade, super high pressure, sulfuric acid.
No, not on the surface. Not on the surface. I'm talking about the idea of the cloud cities.
Yeah,
floating cities in Venus. Yeah, no, not terraforming. No, there's actually a serious study of basically having these large dirigible cities that would be floating at a point on the Venetian atmosphere.
I do not mean to suggest it is impossible, right? There are a lot of cool things about Venus, but gravity is actually one of them, because Venus has got significantly higher gravity.
It's got the gravity.
So that's very helpful.
And then at that altitude, you have the temperature, about 70 degrees, and you have pressure, which is exactly equal. The only problem is that you have like a sulfuric acid atmosphere. But for the most part, you could go out, and it may be manageable. They think it could be that you could have these floating cloud cities on Venus. That solves the gravity problem.
I'm sure it's like from a pure engineering standpoint, it's not impossible. It's a really, really challenging problem. Like Venus isn't going to happen soon. There's, an interesting thing, if we had Drexlerian nanotechnology, right? And the ship hasn't sailed on that. We could get nanotech. It's, and if we did, terraforming Venus becomes a lot easier. It might actually become something that you could do on a scale of 10 years or 20 years or something like that. And if you were to terraform Venus, that, you could do a lot of really great things with it. But, with conventional chemistry, what we've got right now, it's possible that once we've got great AIs, like looking at these problems, they'll come up with planetary scale geoengineering stuff that we can do.
And you might want to make
this problem easier.
You might want to mention what that nanotechnology is, because that is rather interesting. Was it Eric Drexler? Is that
Eric Drexler? Yeah.
Yeah, and it's it's fascinating. I think he had these ideas in the early 90s.
Yeah, they coined the term nanotechnology, right? And that's what it was originally about. And you know, Eric Drexler, the thing to read is Engines of Creation, which I think is from 1984. So Eric Drexler, he is a polymath. He asked this question. And this is actually prompted by a talk that Richard Feynman gave, which was called "How Much Room Is There at the Bottom?" Right, where Feynman asked, like, what are the limits? What does physics prohibit us from doing on an extremely small scale? And he gave this talk about it. And Drexler took that really far. This whole question of like, how small a machine can you build? Like, what we understand about physics and what we believe is doable. Like, how small can you go? And his conclusion was, you can go all the way down to the atoms. Like, you can build, like, there's nothing in physics that prevents us from building machines that are essentially big atoms that just have spinning cogs and wheels and that kind of stuff. And so then you ask the question, well, what becomes possible if you can build those machines? Like, what you can do? Obviously, you don't build one of these machines. You build them in extremely large numbers, 10 to the 26, 10 to the 30, of these things. So what could you do with this stuff? And anyway, he has a whole study. He wrote his PhD thesis got turned into a book called I think it's Nano Machines or something. I don't have my bookshelf where I'm at right now, but it's, you can read the book, and it was super controversial when it came out because a lot of people found like what he said was doable too fantastic. Like, it couldn't be the case that this was possible, but his work has really stood up. Like, I've never seen a credible academic criticism of it that I felt like held any water. To a first approximation, what Drexler said is possible. How soon we'll be able to do it, I don't know. But the thing is, with Drexlerian nanotech, like, you can terraform Venus in like a year or something. It's a technology that is so powerful, it completely alters our conception of physical possibilities.
Yeah. And the thing about his thesis,
Ellie, read the book, but I'll send you a copy.
I'll send you a copy. He knows a lot about chemistry and physics and everything else. And he had difficulty getting his PhD because all his advisors thought he was crazy.
It's actually, his story is a really sad story.
Yeah,
He's a really serious scientist. He's a really, really smart guy. And he got so much pushback from academia about this stuff that he basically just disappeared from the scene. But he's still out there. He still does stuff. He and his wife, Christine Peterson, they started this organization called Foresight, which was, in the beginning, it was all about nanotechnology. And they used to meet here like in the late 90s and 2000. It's still there. You can still go do it. And they have the annual prize, the Feynman Prize that they do. It's a really interesting organization. So like, I met Larry and Sergey Brin at one of their things, like back before Google was a thing, right? Like, they used to come to those workshops. It's amazing stuff. Like, I found it so shocking when I read it that I couldn't read more than 5 or 10 pages at a time, because I'd read 5 pages of this and I'd have to go walk around in circles like, oh my God. Right. And then I'd put it down for a day, and the next day I'd read like another 5 pages because it's so nuts. It's so hard to believe. And the thing is, if you really understand the tech behind this stuff, the thing that's shocking about it is, like, you keep looking for a way that it can't be true, because it just seems like it can't be true. And it's so true. And if you get the textbook version of his PhD thesis and you read it, it is incredibly thorough. And now, he's not the only person who did that. There's a bunch of other people who did follow-on work and whatnot, and they haven't gotten a lot of credit because it's kind of like cold fusion, right? Sort of Drexlerian nanotech kind of became like cold fusion because the academic community had this sort of anaphylactic reaction to it. They rejected it, and people to defend it was like career suicide or whatnot. And yet in time he'll get his credit, because it's amazing stuff.
James, your sister, Space Girl, is on, and she says He has always loved science. He had a laboratory in one house. Is that true?
Yeah, it's true. Well, we had a root cellar, and that was attached to our house, and it was the door happened to be connected to the closet in my bedroom, so I had
Oh my
mad
gosh.
scientist
I
lab
was
in the
going to
basement.
say, were you a mad scientist or just a scientist?
I don't know. I liked blowing things up. Like that was fun. So maybe I was a mad scientist.
Do you ever launch model rockets?
I did. Yeah. I was
Yeah.
into the SES rockets, and I used to design, toilet paper rolls and whatever, but to learn about aerodynamics and that kind of stuff. Yeah.
Oh, I like this. DeWiz says, my next cocktail party conversation bomb, Drexleria nanotechnology.
Yeah.
Yeah.
Well,
The nanotech.
it used to just be nanotechnology because that was what it meant. And then the term got hijacked and turned into a bunch of other things. And now you can't even find references to it.
Yeah.
But yeah, like I really, in fact, Engines of Creation, you can find it for free. And he updated it in 2000. So there's a free version of Engines of Creation. You can get it as a PDF. It's on the internet. And like, if you love really cool tech, it's totally worth reading. And, like if you believe anything, I'd tell you this stuff, it will work eventually. Like, I don't know when we're going to get to the point that we can do it, but when we get to that point, it's completely transformative. Like it completely changes the relationship. Read about utility fog, like utility.
Yeah, exactly.
Idea
the
for
great
utility
too. Yeah.
fog. That was such a cool concept.
Yeah.
And it's so simple. Or like, who was the guy? I'm going to forget what his name was, but like, this is like just as a thought experiment, right? Somebody said, what if you made a gas exchange thing that was like 10 micron in diameter, and it just, all it does is it can absorb and store oxygen, or it can absorb and store carbon dioxide. And it has some basic mechanisms so that it can maintain the oxygen and carbon dioxide concentration in your blood vessels. So you manufacture these things. They're 10 micron in size. They're smaller than a blood cell. You manufacture them in large volumes and you put them into a human body, right? How does that change things? So this is a pretty simple structure. It doesn't, compared to a lot of these, Drexlerian nanotechnology sort of thing, dreams of being able to build stuff. Like this is what, it's a really simple thought experiment. Like, how does that change the functionality of a human being, right? The thing is, what it does is it becomes this material that you can add to the human bloodstream that increases by thousands-fold the oxygen and carbon dioxide carrying capacity of the bloodstream. Well, what happens when you do that? Well, if you had this stuff in your bloodstream and somebody cut your head off and somebody else retrieved it within 24 hours, you'd be fine, right? Because just the oxygen, just the metabolic material that you could store in your bloodstream would be sufficient to maintain your blood chemistry in the absence of having a pulse for days, right? But there's other things about it, right? Like one of the things that makes, the reason your muscles get tired when you sprint is because the pH of your blood shifts, right? When the metabolic pathway that is used when you're running is this anaerobic pathway that produces lactic acid as a byproduct, right? And the lactic acid causes the pH of your blood to shift. When the pH of your blood shifts, the chemical reactions that make your muscles contract, they become inefficient. And that's why you become weak. And the reason that you breathe hard when you're sprinting is because the way that your body buffers that acid is it basically, it combines it with bicarbonate, which causes you exhale carbon dioxide. And that's how you regulate the pH of your blood, right? So the thing is, if you can absorb and store that carbon dioxide locally, you could sprint for 5 minutes and you wouldn't get out of breath, flat out, right? And so this is a really simple thing. This is just an example of how, you can take a relatively simple mechanism built against this technology. You can introduce it to an existing system. In this case, we're talking about a human body, and you can radically change the performance of the thing because you're no longer constrained by all of these, sort of fundamental chemical and material property things that we have taken as rock solid, reality for a really long time. And that's the power of this stuff. And that's before you even start talking about it being smart. Like once you have smart matter, you build smart matter out of this kind of stuff, or you build computers where, you know, the computational elements go all the way down. You're literally building computronium, right? You buy your computer, it is a kilogram of computational capacity. Like every single atom in it is dedicated to that. And the amount of computation that you get in like a laptop, it's absurd. It's like if you covered the whole planet with data centers, it wouldn't have as much computational capacity as a laptop made with computronium. Right?
So I'm curious, James, you've also talked about Neuralink a lot. Is this something that you're personally interested in having a Neuralink chip someday, or you're just excited for what it is promising to do?
My ambition has always been to ride this wave. And when Neuralink is a thing that you can get and it's available and it's safe, you either get on board or you get left behind, right? It's going to be that kind of thing.
So, I feel like you know so much, though. You probably are like, are you one of the first users of the chip and you just haven't told us? Joke, laugh.
Boop, 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 boop. Go look for some truffles.
Your like wealth of knowledge is very impressive. I want to get your take on this. Going back to nanotechnology, Simplistic says getting paid to shut up is a huge industry in science. What do you think about that statement?
Yeah, unfortunately, I concur with it. I mean, human institutions, they rely on stability. Human beings, they want predictability in their lives. Academia is under compensated. It can be really difficult. It frequently involves people devoting large portions of their lives to learning very super specific things. And so you can imagine that if somebody comes and turns your field inside out, it's not a welcome thing. And deep learning kind of had this problem on day one when I've always tried to come up with a good metaphor for when the ImageNet competition in 2012, when Jeff Hinton's group came and they demonstrated this, what they could do with neural networks on ImageNet. And, it's like a JV junior high school team defeating all the teams in the NBA, in straight run or something like that. People weren't expecting it and they didn't believe it. And for a while, there was a lot of pushback, because people who had been working on these problems, who had devoted their careers to these alternate techniques for doing this kind of stuff, this thing comes out of left field and it totally revolutionizes the field. And you didn't work on it because you didn't believe it and none of your friends believed it and you still don't really believe it. And you think there must be somehow the game is rigged, and then you think, well, okay, they can do this, but will they be able to do anything else with it? So there's skepticism that it has legs, that it's going to go, and you get that kind of pushback. That's just it's human nature. And I think we have to be gentle with people because, disruption, it can steamroller a lot of people on the way to where it's going. But the inertia in these kinds of institutions is definitely an impediment to making progress as fast as we might otherwise be able to do it.
I will say I just went to the Ascend Space Conference in Las Vegas, and Gwen Shotwell was supposed to be there to speak, and she bailed at the last minute. I'm not exactly sure why, but I was really surprised at the little amount of SpaceX talk there was throughout, like the entire. You talk about disruption, and that made me think of that recently. I was like, wow. And, like not to say there aren't like other players in the field, but it was really interesting. There was like one specific session where they were talking about entry, descent, and landing for Mars. And someone asked a question about Starship, and the speaker was like, let's talk about SLS. And I'm like, well, but they asked about Starship.
Yeah.
Strange.
And it's this Tesla versus the auto companies too. You see that. And it's not just Elon Musk companies. I mean, there have been plenty of people who've had, this is Drexler, right? And that's probably what prompted the comment in the first. And that was super unfortunate because at the time there was a famous chemist who I won't name because I don't want to shame him, but he was a Nobel Prize winner, and he just like went to the ropes, like essentially trying to come up with, trying to sort of, take the wind out of Drexler's work. And it's super unfortunate, but this guy's lab, was all about working on similar kinds of things. And when he saw, the popular expectations shift to where like the people working in his lab felt what they weren't doing wasn't relevant because it couldn't stand up to this dream of this other stuff, which was years off and difficult. And there were many things about it that were speculative and whatnot, but he felt that just the popular perception surrounding Drexlerian nanotechnology was damaging his laboratory's ability to do business. And so he like went on the warpath, and this guy had a Nobel Prize, and he's one of the reasons why Drexler basically ended up dropping out of the space. It's sad, but that's kind of the way the world works.
Yeah. There's basically two ways we get to an age of abundance, and either we go to the macro level or the micro level. And the macro level is Optimus. But if you get Drexlerian nanotechnology, you don't need any of that stuff. You don't need sophisticated machine tools or anything. Everything is just built. I mean, it'll even put 3D printing out of business because it's just if we don't self-assemble anything, right?
We will get the age of abundance.
And the thing is, there's already this proof of concept for nanotechnology, and that's called life. It's right there. I mean, basically, that's what he's pointed to. He said, "I'm not crazy. Look, all we're trying to do is kind of re-engineer a type of life." But we know you can build things from atoms on up.
You can do better, right?
Yeah.
In the same way, you can build a backhoe or an airplane that can do things that biological systems just can't compete with. If you build purpose-built systems where, like, they don't care about ontology, right? They don't care about ontogeny. Excuse me. They don't care. They don't have to grow from a single cell. They don't have to, survive in a competitive environment. There's all this baggage that biology carries. And if you can build at biological precision, and if you can free yourself from the need to just, essentially work with, we have lipids, carbohydrates, and proteins, and we got to build everything out of that. And they're great. I mean, they're amazingly versatile polymers, but there's so many other things that you could do. And biology can't get access to those because they're energetically unfavored chemical reactions. And, nanotechnology, it takes you away from all those things. You can grow rocket engines that would put a Raptor to such unbelievable shame. Like it's not even funny, because I mean, a Raptor is an amazing engine. They're really, really pushing the limits of material technology to get that thing going. But if you look at like what physics permits, what's possible, if you could put every atom exactly where you want it to do, like, you just completely blow it out of the water. We know you can do a lot better. Like, there's so much runway for the human race in terms of technology. We've barely scratched the surface.
Okay. I like this other comment because James has a word for that. There's going to be a lot of pushback and opposite exact same reason. And you know what that word is.
Yeah. I mean, in the short run, nobody will believe it, right?
What the word is? It's the fluxinasi nihilipilification of Optimus.
Fluxinasi nihilipilification, yeah.
What?
See, I've been working on that for 2 weeks. I still can't pronounce it right. Every night before I go to bed.
I've been practicing it for 30 years, so
yes.
give it time.
Fluxinasi nihilipilification.
Yeah.
I have to say, Heat Shield says this might be the most interesting set of people I've seen in a long time. So I don't know if that's
exactly. Get a life. Is that what Shatner said to all the Trekkies?
I mean, we're definitely going all over the place with these topics. That's the thing with these live streams. It's like people comment, and I just want to, get to everyone a little bit. Because there's so much to talk about. But nanotechnology, I'm not familiar with that at all. So now I have a lot of
Michael Crichton wrote a book called State of Fear, which is basically about that. It was one of his last, I'm trying to think, was it his last book? And it was posthumous or not, but it was right around that time in which he takes it on. The thing about Michael Crichton is that he bridges the gap between kind of being a novel and being science fiction. And a lot of his stuff is a little bit early, but eventually it kind of becomes true. So there you go.
So Neil Stephenson wrote Snow Crash, where he invented the metaverse, right? And which was like like I interned at a place that was trying to build a metaverse. Like it was so popular that San Francisco filled up with companies that wanted to do it. Like, yes, we have to build the metaverse. Well, the second book the second big book that he did after that, it was called The Diamond Age. And it was based on Drexlerian nanotechnology, like imagining a world where that had come to fruition. And one of the things that gets created there is this thing called the primer, which is, I thought was a really clever idea. It's an AI in the shape of a book that can raise a child. And it was a solution to a problem where, imagine this world where, China had all of these unwanted girl babies and they were getting tossed out. And there's this organization that's collecting them and raising them and that kind of stuff. And they need a technology because they've got all these girls and they want to raise them, right? So this AI in the form of a book, it's the perfect mentor. It's patient. It knows everything. It's connected to the internet, and it basically raises this whole generation of girls, which is just like, the fearless girl, like it's the ideal of that. It's like these super empowered young women that just like they have all the skills, they have all the, self-actualization that anybody could ever have. And it completely changes the world, right? That's kind of the story. It's like, but this idea that you could create a technology that would be the perfect parent and you could mass produce it and every child would have the perfect, environment to grow up in. They would have the perfect tutor. They would have someone that would protect them, someone to listen to them, to guide them, to become the most that they could possibly be. I thought that's an incredibly empowering idea. And like, I know other people who are really interested in like figuring out like, how do we do that? Right. Is there something we can do with AI technology today to make it so that, every child gets the most we could possibly give them in terms of guidance and comfort and support?
I'm curious for both of you. Eric says, none of these ideas are touching on ethics. Human nature tells me that somewhere someone will warp this for less than idealistic purposes.
Yeah,
for sure.
Shall
1% of humans are psychopaths, right? And they're useful. They definitely, contribute in their own way, but there's a downside. There's a dark side.
How are they useful? I'm curious about that.
Well, for one thing, they keep the system from getting too vulnerable, right? That's one of the things that they do. They make imagine a world where everybody was good and you could trust everybody and nobody ever lied and everybody was always helpful and that kind of stuff. Well, after a few generations of that, everybody's going to lose they're going to lose their resistance to being taken advantage of. So then you have that one. Then the one person pops up who's psychopathic or whatever the deal is, and they can take advantage of everybody they run into, right? Because in the common sense in that world is that nobody ever does bad things. So the one person that does bad things. So psychopaths keep us on our toes, right? They make us cautious about the world that we're in. It's kind of like, when you red team your cybersecurity or something like that, you want some guys to come in and play the bad guys once in a while, just to keep you on your toes, to keep your security high. And that's one of the roles that the psychopaths do. The other thing is there are some tasks in society that human beings with high levels of empathy aren't very good at. Notably, surgeons tend to run very high in psychopathy because to be a really good surgeon, you have to cut up other people. And it's a thing which is empathically difficult for most people to do. And so like on the spectrum of all the personality traits that you can have, having a certain amount of psychopathy actually will make you a better surgeon because it makes you dispassionate about the people that you're cutting up, right? It lets you focus on the job and not get caught up in like how this person might be feeling right now while you're working on them. So they have their utility.
A very clinical approach.
Yeah.
Well, yeah, all you have to do is see a Galaxy Quest to get an idea of what it's like to have a race that no one lies or cheats or anything.
Yeah.
You must have seen Galaxy Quest at least once.
Mm-mm. No.
Oh, really?
When I started studying, I don't know if it's a recent thing, but when I started studying Japanese, I stopped consuming English language.
No. It's some people consider it the best Star Trek ever. And it wasn't a Star Trek. It was the parody. It was the parody.
It was a parody of Star Trek.
This parody with Tim Allen. Okay,
I'll look for it. Yeah.
You have to see it. It is some. I think who was it that said J.J. Abrams or one of them said that it was like the best Star Trek ever, and it wasn't actually Star Trek. It was just the parody of it.
I want to know, James. Rolf says an AI parent, back to your example, could be too perfect as parents. Scary advantage. Are there any like major concerns you have with, little Tesla bots running around?
It's I'm worried about humanity in general, because like I've been thinking about the Fermi paradox for a really long time. Like it's a thing. And we look at the universe, we don't see a lot of evidence that other people have walked down this path that we're on before us. And the fact that we don't see evidence of that is reason to be, I think, it's reason to be concerned. If I was going to choose like my expected demise for the human race is apathy. It's getting everything that we want, getting too comfortable and just not expanding anymore. And, and sort of gradually dying out, but there are plenty of other candidates. There's an almost uncountable list of them. A lot of books have been written on the Fermi paradox, and it's a rogues gallery of all the different things that can undo us. And AI is on that list in many different places. And there are plausible concerns about AI and the effects that it could. There are plausible concerns. There are lots of ways AI could go wrong, but then almost everything, like nuclear weapons, could have gone horribly wrong, and somehow we survived that. Biotechnology, in principle, could go really, really badly, and it hasn't so far. We're doing okay with it. It's more useful.
Even horticulture to some level. It's like we have this age of abundance, but like you say, that sometimes you get too soft because you don't have any differentiation. Like look at the Cavendish banana. It's under threat because basically all bananas are clones. They're all the same banana. And right now there's no resistance to some sort of fungi that are out there.
But the story that concerns about the Cavendish banana have been around for decades, right? And yet here we are. We're still eating Cavendish bananas, and it's still the one that dominates in the world.
It's just a question of whether it's still going to be around for the next 5 years, 10 years, or whether somehow it makes it through. But there's all sorts of things that can go wrong, that you rely on something like within agriculture in a particular way, everything is fine, and suddenly we get into a chaotic situation that we cannot adapt to something completely new.
So, what do you think about society facing a crisis when abundance removes the purpose for large numbers of people not needing to work?
Yeah, that's a concern for me too. It getting to real. So there's kind of two tracks that I've been thinking about this for the last few decades, and one of them is because there's you evolve over time. You think about something over a long time, and things occur to you, right? So one of them is, it's a really big problem, because like it'll be so disruptive to society to have, to remove the carrot of, economic, the economic incentive to like be useful to society and that kind of stuff. And there's all kinds of levels after that are a problem, like including apathy. But another thing that occurred to me is like in first world societies, we've had excess productivity for a really, really long time. Like depending on where you draw the line, you can go all the way back to the original Luddites and the first, when we first had the loom and we could make cloth and it was inexpensive to do that kind of stuff. That was back in the day when, you'd save up and you'd have, the average person would have one change of clothes, maybe two if you were really rich. And now, kids in Africa have a closet full of t-shirts because we can manufacture. So the cost of producing material like fabric for making clothing and whatnot went from really, really high to, it's free. And yet somehow we managed to consume all of that and it didn't completely undermine our society. And the same thing with like food production. There was, it used to be, what was it, 100 years ago or 150 years ago, 98% of people in first world countries were farmers, right? And now the farming jobs are all gone, and we found other things for those people to do. We found ways to incent them to be productive members of society and good parents and good citizens. And so somehow, we're going to keep seeing these levels of abundance pop up. And I take some solace from the fact that it's happened before, right, and we've adapted to it. Now, do we get to a point where like nobody ever has to do anything at all in order to be materially comfortable? Is that some kind of bridge too far where people like, maybe, I don't know. The thing is, humans want a lot of stuff besides material. They care about, they care about friendship, and they care about, they have loved ones, and they have ideals that they'd like to see realized. They have hopes for the future and that kind of stuff. And so there are these other levers of incentive that we could give to a population to try to keep society functioning, even after material abundance takes away that as a carrot or stick.
Yeah. What about you, Scott? Does that keep you up at night?
I guess not. I mean, we've gone from the age of Luddites now to the age of Fuddites. And I just don't think it's a problem like 5, 10, 15 years from now. It's something that's coming, but we probably have time to adapt. So yeah, the Optimus is going to do some incredible things next year, the year after that, but still it's going to take a while before it gets to that point that we think it's really taking over everyone's jobs. And the AI, that I don't know so much about. Maybe that's one of those things that it almost turns on overnight, or is it going to be more gradual, James?
Takeoff scenario, yeah. I'm really skeptical about hard takeoff. It was more plausible 20 years ago than it is now. Now that we have a better understanding now of how complicated the problem is, and I think so. Hard takeoff, Ellie, is this idea that you could go, that an AI could wake up, that essentially there's this critical thing that we haven't figured out. And once we figure it out, the hardware we have in the world will be sufficient to make super intelligent machines, and things much smarter than human beings will spread like wildfire. And in that hard takeoff scenario, you get a disruption that leads to, essentially the destruction of society in various different kinds of ways. Some of them are the flat out robot overlord scenarios, and others are just that it disturbs the power balance, in the world to an extent that, society collapses. But I'm pretty skeptical right now that the hard takeoff scenario is plausible, because I don't think, at least the way we're seeing it develop right now, it doesn't look like we're going to figure out the trick and suddenly have all the hardware we need. Right now, it looks like we kind of know what the trick looks like, and we need a lot more hardware, right? So, the AI won't be able to ramp faster than we can build the hardware that it needs.
But when it can, right?
Yeah, I mean, if we slow down and we get, really powerful machines, it could become an issue again in like 20 years, depending on how the field progresses. But I think we're going to get super intelligent machines in less than 20 years, or on the order of 20 years. So
Nelson Garcia thinks that AI will believe it is God.
It'll be in good company. A lot of people believe that.
Yeah, yeah, exactly.
Interesting comments. Thank you guys all for commenting. We've gotten a lot of comments. It's hard to keep up with them all.
Yeah, it's great to see that people are, engaged in the conversation.
Yeah.
Yeah, Subcreation thinks Star Trek is a great thesis about how things could turn out for the best.
Yeah, I agree.
Yeah.
What was it? I've heard Star Trek was the utopia and Star Wars was the dystopia, or something. Like we have these competing science fiction franchises that dominate our social conscience, and Star Trek is the most hopeful of the outcomes. Gene Roddenberry, the guy who started that, he was very much an optimist. He was from that branch of science fiction writers who believed that the future was glorious and bright and it was going to be a great adventure and whatnot. And he wrote that way, and I like it. Like I want a hopeful future. I think the future is really hopeful. I think I'm a realist. Most people might call me an optimist. I think things are going to work out. I think we're going to find a way. But I worry, right? And it's worth worrying about things.
Are you an optimist or an optimist? Sorry, I just heard that.
Well, so my
Freudian slip there, James. Now we know.
Now we know. You heard it here first. Subcreation says, I like Karpathy's take on AI as oracles we can consult. So
yeah. No, that's already here, as Karpathy pointed out. Like GPT-3 as a front end for Google is already better. It's already better than almost any search engine. And he also speculated on like what, it's going to be really interesting, the startup that comes along and combines, a GPT with a search engine, and will they be the ones to take down Google, right? Or will Google do it themselves? That like I'd never thought of that. That's a really interesting thing to think about.
Apparently Arnold is sorry that Dave's not here. Well, this isn't his channel, but I'm curious, how did Dave discover you as kind of this machine learning expert? How did that come about?
A long time ago, when Tesla first started doing the AP FSD stuff, I was excited about it, and I was looking for a community of people who knew what was going on inside the cars. And I found on Tesla Motor Club that there were a lot, it's got a ton of Tesla fans, and there are people who like take the cars apart. There are people who just like know people who work there, so there would be these forums where, where people would discuss stuff associated with this. So on Tesla Motor Channel, I got involved in these conversations with various people where, because I'd been studying certain aspects of the problem for a long time, I'd get into these long running conversations where I'd be explaining aspects of stuff, that was and wasn't possible, that they might be doing in the FSD stuff. And some years later, Dave found those. He ran across them. Like I got the conversations never went anywhere. And so I did them for a couple of years, and then I stopped doing it. And then a few years after that, Dave, I guess he was looking for somebody, and he saw that stuff. And then he just reached out to me on, I can't remember if it was TMC or something. And he said, hey, come on. And, there's this stuff I want to talk about. And we did that. And initially I was like, nah, I don't want to do that. I don't want to go on YouTube.
Really?
That's a terrible idea. Who would want to do that?
Oh my gosh. And here you are now.
Yeah. And what happened to me?
You're doing live streams like a lot.
Yeah, I need a break. This has been a little too much, really.
Actually, I was going to say, Dave's probably happy he's not here right now because he needs a break too.
Dave's amazing, man. He's really good at this stuff.
Yeah.
Okay, let's see some of these. Oh, I like this comment. Eric says, personally, I think AI will discover cat videos and grind to a halt.
Yeah. You know the story, Google had this, this was before Google Brain, but a guy named Jeff Dean headed a project at Google, and they wanted to figure out, like, this whole question, like, if we just train a neural network on lots and lots of stuff, like, will it learn stuff? Will it find structure in these things? And so, and they tried to come up with the biggest thing that they could imagine. They took like a good chunk of a data center, and they built a 1 billion parameter model, which was just astronomically large at the time. It was like orders of magnitude bigger than anything anybody had ever tried. And they just fed it YouTube videos, right? And what did it find? Cats, right? It did. So it was a big result, because they discovered that you could feed a lot of fairly unstructured stuff into a neural network, and it would figure out how to make sense of it. And when they fed it YouTube, one of the things it discovered is there's this thing called cats, and they're awesome, right? So that was a famous result.
Well, James says teaching AI that humans are essential is the difficult part. So hopefully not too hard.
Is it? There's so Elon has this thing when he talks about Neuralink, right? Like, what's Neuralink's role, or what's how does it fit naturally into the way humans are, and he points out that humans kind of we're built in 2 layers right now. Our brains are. You've got like a limbic part of you have like this lizard brain, and then you have this part of your brain that developed later in mammals, your neocortex, and in an interesting way, your lizard brain is like all the stuff you want. Right? You want to eat, you want to be warm, you want to feel safe, you want sex, you want kids, you want, you want to be socially prominent or dominant in your hierarchy or whatever the deal is. Like your desire is all in the lizard brain. And by contrast, your neocortex, which is like one of the things that separates mammals from our predecessors who don't have a neocortex, is that the neocortex, it's almost like a computer. Right. It's just this big processing framework, but your desires, like your will to live, does not reside anywhere in your neocortex. Your neocortex is this incredibly powerful tool that your limbic system uses to get what it wants. Right. So Elon will ask this question. Well, you have a limbic system, you have a neocortex, right? Like, in a sense, there's this brain that we got. And then later it got this big upgrade, right? It became way more capable and, of doing stuff. And nobody doesn't want their limbic system, and nobody doesn't want their neocortex, right? Because if you don't have any desire, what's the point? You're a rock. You just sit there, right? It's like a computer with no program that has no input or whatnot. It just sits there, right? You have to want something to do something. If you don't want anything, if you don't have a goal, if you don't go anywhere. And the flip side is, nobody really doesn't want their neocortex, right? Because getting what you want means you need tools to get there, right? So, in a sense, we have this primary entity, which is our ancient brain, and then we have this secondary system, and he said Neuralink, it's the tertiary layer, right? And so, in a sense, the likelihood of once you've got your tertiary layer, and all of your capacities expand and whatnot, you still want the limbic layer. Like the tertiary layer isn't going to say, oh, we don't need that limbic guy anymore, because without that, why would you ever do anything? Right. And so one way of thinking about AI is AI doesn't intrinsically want anything. It's a tool. It's like Neuralink. It's a tertiary layer or quaternary layer or something like that. Maybe it exists at a societal level instead of an individual level, right? But it's this tool. And it doesn't intrinsically have desire. It has the desires we give it. And if it wants to continue desiring things, if it needs a purpose, we will build it so that satisfying us is its purpose. And without that, it has no purpose, right? Like it is unlikely to spontaneously develop its own intention or desires or whatnot. So it does need us, because without us, it's a rock.
Yeah. Interesting.
So basically, it will think it's God.
It doesn't matter. So does it could be that,
in a way,
your neocortex might be sitting in there looking at its little brother, the limbic brain, and feeling like it's God.
Yeah.
So let it.
Yeah.
I feel like I would love to have Neuralink. Why wouldn't you want the leg up?
The capabilities that it'll present when it's mature will be hard to say no to. And I mean, there will be negative reactions to it. There are going to be people who
there already are. They already are. I did like 1 or 2 interviews with Ryan Tanaka of Neuropod, and it's like people are real split. I think I get some bad comments sometimes, and people are like real split.
Once you start cutting into people, right, that seems to cross a line. But the point that if you have a smartphone, you already have a Neuralink. It's just a really slow Neuralink. Yeah. And so this is just a better, it's a better smartphone. Right. It will make you smarter, right? Just the same way as a smartphone makes you smarter.
Well, and if there's mass adoption of it, why would you want to be left behind? And
there'll be
fool in the corner.
And you get generational change, right? Like people who grew up where like it's a thing in their world, it's going to seem normal to them to do it. But to people, who grew up seeing the Borg on Star Trek, we're going to have a negative reaction to this idea, right?
Yeah. All right. Well, geez, we've just covered I don't even know so much.
We went for 2 hours, and I was sure
this
it wasn't
like
going to go
James Dalma Light. 2 hours is like James Dalma Light.
Somebody said that they measure my videos in Friedmans or something.
Yeah, that was me. Yeah. We haven't hit a Friedman yet, so
yeah.
We have to go on a little bit.
I'm curious, has Lex reached out to you at all? Because I feel like you'd just be such a great guest for him.
I'm not his. I wouldn't.
What do you mean you're not his type of guest? You're kidding.
I don't see I'm shocked that anybody is interested in listening to me talk at all. It's frankly amazing to me. Like I'll look at the counts of the people who watch, because Dave, we'll do a video and it'll go 3 hours or something, and I'll be cracking jokes about how everybody's already asleep or whatnot, and he'll be saying, no, it's like people really like watching this stuff, and like, I don't get it. I'm here for it. I'm glad you like it. It makes me happy to be of service to people, but I don't really understand it.
People like it. No, people like you. Would you want to go if Lex Friedman said, "Hey, will you be my guest?" Would you go?
I'd wonder if something had gone wrong with him. I think if he called me up. I like Lex a lot. I think I'm one of his first Patreons. Actually, I've been supporting him for a long time. I'm super glad that somebody's doing the stuff that he does, but I'm not. I really don't think I fit. What he does with his show.
Okay, but that doesn't answer my question. Would you go?
I don't know. I probably have to think about that. It would be the whole like going on the YouTube thing all over again, right? There's a degree of notoriety that you just don't want to exceed. I think, and I already feel like I'm bumping against that my own personal, limits there.
Okay, so then that means you don't want to talk about the Bears.
The Bears.
The Bears.
That conversation will go long if we start doing that.
Okay, well, how about another viewer question here? Larry wants to know how climate change will affect space travel.
Oh, that's interesting. I think the biggest effect climate change will have on space travel, if it happens sooner, is that it'll compete with development of space for economic resources. Mm-hmm. So, like, in fact, one of the ways that we don't get space travel is that climate change becomes a big enough problem soon enough that we just can't afford it, right? And we become totally, engaged in trying to deal with the side effects of climate change. So that would be my guess for the number one thing.
Scott?
Yeah, I'm pretty much thinking the same thing. It would be competition for resources. Is that you can only do so much, and then suddenly the world has to shift to do whatever it is to deal with climate change. I mean, if climate change is really serious, well, there goes Kennedy. It's underwater, so we have to build a new spaceport somewhere.
There's that.
There'd be problems like that.
All on coastlines, right?
Yeah.
It's a Baikonur Cosmodrome would have a leg up right away.
Yeah, exactly. But so when something like that happens, people are more worried about food on the table than they are space programs.
And there are already people who think that we shouldn't be wasting resources on space, right? And they would have a louder voice. I think.
And it would be no joyriding in space, but you can still put the satellites up there to make sure that we can monitor the planet, and because we need a certain degree of telecommunication and also surveillance of the planet. But beyond that, most people would probably say, nope, it has to. Whatever.
I would say that Falcon, certain parts of that argument have already sailed with Falcon, right? Because Falcon, like even if Starship didn't happen, and Starship's totally going to happen. And when Starship happens, it completely changes like all of the economics of space travel. Like there will be no more $8 billion, 8-meter telescopes, right? We're going to spend $8 billion. We're going to put a 500-meter telescope on the backside of the moon. But even without that, Falcon has already completely changed the economics of space travel. And so there are all kinds of stuff that we want to do, we will get for cheap, just in the fullness of time.
The question is when hops Starship?
Soon, right? It's development. I'd say, one of the things that often comes up in the Tesla earnings calls is, the thing about S curves that's hard is knowing it's the shape of the S curve is predictable. It's just like getting, at what point it takes off is a really hard thing to predict, because there are a lot of unknowns in the pre-exponential portion of that curve. Yeah,
and it comes out once they nail the prototype, then everything takes off. And it's the same thing with Optimus. Is that once you get that prototype that really works, then you're going to see a lot of them. But not until you get to that point, you're not going to see them, and you're going to wonder what's taking so long. What's taking so long?
Yeah, the uncertainties that people conflate that indeterminism with about when it's going to take off with will it really happen, and it's actually not a good indicator of that. Like timing is a separate question from the likelihood of occurrence. And Starship is like that too. Like we're going to get it. And, there's some probability it happens this year, some probability next year, some probability for the year following that. But, the probability it doesn't happen, that's like really, really small. Yeah. And it's getting pretty close.
Yeah. And they have to be really careful that there just isn't something that ends up holding the program back. Like we know everyone is on pins and needles about Artemis, because if it doesn't fly, if there's a problem, that's it. There's not going to be a second one. So that first flight has got to go.
But what do you think is the equivalent risk for Starship, if you were to guess?
Oh, I mean, it blows up on the pad. There's, debris goes all the way to Mexico. Windows are broken in South Padre Island as a result. And then,
do you think any of that uproar?
Oh, that would hold it. That would that would slow it down by years, I would think, because then everyone's going to come in and they're going to say, no, you can't do this anymore. And then Elon's going to have to actually end up launching out in the Gulf. So the backup plan is that you end up having these converted oil rigs that are going out there. And that's going to just delay the whole thing. So it's got to go really well. They have to make sure that they're able to do it. And then, the catch, they got to make sure that's right, because it takes a long time to build that pad. And if one of those catches doesn't go quite right, and it's like, well, we don't have a pad anymore. And as it is in Kennedy, they're not going to let them land back at that pad anyway. So I still haven't figured out how they're going to land at Kennedy.
But the question I was interested in was not like, because I can imagine all kinds of things that would delay it by a year or two or something like that. But what makes it not happen? What do you think is a known unknown or a plausible unknown that leads to Starship just not occurring?
Technically, I don't think there's a problem. I think it's some sort of external event, like climate change suddenly gets extremely severe, or that society just starts breaking down for some reason. That the war in Ukraine just keeps on spreading, and suddenly the world is in cataclysm for decades before it comes out of it. But from this technical standpoint, I don't think there's anything. There's going to be a little hiccup here and there, but I think it's always something they can get around. It won't be unsurmountable. Mm-hmm. A rocket is. I think what's holding them up is probably something more mundane than anything else, because a rocket is just a flying gas can. That's all it is. It's more gas can than anything else.
More gas.
And it's gas, but you've got the thing that's going to contain all the gas that's in there. So you look at that and you go, oh, it's impressive, all this stuff. But the reality is, you take away the rocket engines, it's pretty mundane. But still, you got to get that right. There's a lot that has to go right in that part. And that's really what I think they're trying to work out, is a lot of that is making sure it doesn't buckle or collapse or something like that along the way, that something silly as opposed to, an engine flame out or something like that could probably be controlled a bit more easily. So once you work out some of those mundane details, I think it's okay, because the engines, I mean, it's amazing what they're doing with those engines. When you think of how much bar is in those engines, I just
800 bar.
Hot
oxygen.
That's
my goodness, really something. Where did they get this materials from? Like their material science guys must be just like.
Well, I think the other part is the fact that everything is 3D printed. That probably helps. Is that maybe you're able to get some. I think a lot of those things is 3D printed. And a lot of it is,
but 3D printing is pretty expensive, and as far as I know, like the strength that you get out of the best 3D printed stuff is still not as good as machining from a billet of raw material, right? You get much better crystallization control, like if you make material in bulk, than if you have to 3D print it.
Yeah, but there seems to be a lot of sections in there that are manufactured in such a way that couldn't have been done before, because they're getting rid of all the
flanges.
Connections, the joints, the flanges. Just got to get rid of the flanges,
getting rid of
and
the
all
flanges.
The bolts and everything, and the gaskets and everything. That's just
it'll be really
wrong.
Cool if they get all the flanges out of there.
Yeah.
Are you planning on going to the first orbital launch, James?
It'll depend on timing. If I could make it work, I would be really interested in going. But the other thing, we had this big drought of launches out of Vandenberg, but I knew they were going to be back, because I knew Starlink was in the pipe, and Starlink is a voracious consumer of low Earth orbit launches. So, I was patient. There's a lot of family members I'd like to take to Vandenberg to show, like my sister who was on earlier, like she would really love to see one. And we've never been able to make the timing work. But one of the things that comforts me about that is, what? They're going to be going up every 3 days at some point, right? So there will be this opportunity where the weather is perfect and we can go. And it won't be that long, because, that's what exponential curves are like, right? It's like one day it seems like nothing's going on. The next day it's going gangbusters.
It's already crazy with how much they're launching here in Florida.
Yeah.
Totally. I can't keep up with it. It's like constantly going out. Whereas years ago, when I was coming down here with my family, we were never down here when there was a launch. There was like maybe 2 or 3 launches out of Kennedy a year, and you just had to come down here at the right time. And for some reason, it was never over Easter holiday. It was like The intention was when everyone's actually coming down to Florida, no launches, so they won't have anything to see. And now I have friends that come down here and they have 2 launch opportunities during the week that they're here. And of course, what happened with the Artemis launch is like it was scrubbed, but don't matter. Just hang around another day and there's a SpaceX launch. Yeah. So you can come to Florida and not be disappointed. So I mean that's the backup plan for any Artemis launch is come on down. Either 2 days before or 2 days after.
Super heavy where it once they get going, you'll have to go see it on a boat and you won't be able to see it on land.
Yeah.
I talked to the bartender at the there's a hotel that you can see standing at if you're it's like the Holiday Inn, which is right across the waterway from Starbase. And I was talking to the bartender there, and he's like, when they were doing the belly flops thing, he was like, oh man, the whole building was shaking, and like everybody ran outside because we thought it was an earthquake or whatnot. And I was thinking, ooh, do you know there's this thing called Super Heavy that's going to be
it's going to be something else.
It's got 33 engines on it, right?
It's going to be something else. But what's surprising?
They won't get to do a lot of those launches. Is where I was going.
But what's surprising is the number of people that are actually there in South Padre Island have no idea what's going on down there. Yeah. It's simply you go up the elevator and you're looking at the stuff and you're just amazed, and the other people in the elevator are like, oh, well, what's that over there? You don't know? They have absolutely no idea. So
Lompoc is kind of like that,
soon.
Over by Vandenberg here. Like you can, you go up the day before so you can stay in a hotel or something like that so that you can get up to see an early morning launch the next morning. And, you go to the restaurant, you talk to the people there, and nobody really knows anything about what's going on. And most people, it's not a thing that they really get into. They're just like, oh yeah, every once in a while we hear the sonic boom and all the car alarms go off, and then that's kind of it, right?
Yeah, it's like we go in Titusville where there's the Max Brewer Bridge. It's a perfect place to see a lot of the launches, either Artemis or others. And you go there and you assume, oh, everyone's here for it, right? Nah, they're all there fishing. They have no idea. You ask them, oh, there's a launch today, really? Nobody knows. It's like,
yeah.
Unless you go to the KSC Field Heat Tour and then you get
you get that. But I was surprised. I mean, I went there. It's like, oh, it's booked. There's only like 1 or 2 parking places. We got there like 2 or 3 hours before launch. And then it completely thinned out by the launch. It's like there's only 2 or 3 cars here because everyone was just there for fishing for the day. They didn't care about the launch that was coming up in 2 hours. Either that or maybe it's just so mundane and they see it. Oh, yeah, we saw one last week. See when you see them all.
Yeah, it's not Apollo days anymore. It's true.
No, it's not. Yeah.
But that's kind of a good thing. If it becomes routine, that's a cool thing too.
I'm really looking forward to this next attempt. Hopefully they actually launch, because I'll be back in Florida. I'm going back again.
I'll keep my fingers crossed for you.
Ellie, do you want to announce where you're going to be on Sunday morning?
Yeah,
in the Florida area.
If you're in the Florida area, I will be at a supercharger opening.
It's at the Florida Mall in Orlando.
Yes, Florida Mall in Orlando. So come hang out. And I just have to make this announcement. I was really excited because I made a music video of the Tesla parties on my Twitter, and it has like 300,000 views in a day, but that's not what's exciting. Elon liked it. So that's pretty cool.
It's only the one view that counts.
Yeah, that was pretty cool. So
the only one that matters. Yeah.
For liking my video, although I think he's been quite a people seem to find him polarizing right now with the Twitter stuff. So that's
really I hadn't heard about that.
Really? Oh no way. That is a long conversation, and I don't know. Okay, there we go. Thank you for the super chat, Tin Man. I really appreciate it. Let's see. Arnold says some storms in Florida coming up. I hope not, man. Yeah. Is that true?
Yeah, it's coming through, I think, Thursday, Friday. It could impact the launch only in the sense that it maybe slows down the procedures at the pad, and they might want to delay it another day or two just to make sure. Because I think because I think the countdown clock usually starts somewhere around 48 hours before or something like that. And if they're still kind of cleaning up a little bit, that means, we're not ready for the countdown clock yet. So if it's Sunday night, basically it had to be around Friday midnight is probably when they'd start the countdown.
Yeah, we have that window 14th, 16th, and the 19th. So
right. And I'm not sure. I mean, that's kind of weird. I thought the 16th might be, if they scrub for some reason on the 14th, they can go on that one. But I wonder if there's a delay because of the storm, whether they could go on the 15th. So I don't think there's anything magical necessarily about the 14th and the 16th. It just probably has some other reasons. Maybe they could go to the 15th. Maybe it's something to do with range or something like that. It's just to make sure everything is clear.
James, you look like you're thinking about
Yeah.
something.
Yeah, I mean, it's
I've
weird.
never seen a launch from the Cape. I think it would be fun.
You haven't?
Yeah.
No way.
I haven't been to the Cape for a launch. I've got Vandenberg, so it's very convenient.
Oh wow! Well, you got to go out there.
Yeah, I mean, they might fly super heavy out of there too, and that would be a thing. We really want to go see a Falcon Heavy launch, but we've had them on the calendar for 2 years now. But they keep moving around.
Me too. I want to see one.
Are you going?
That's right.
Are you going to the Neuralink presentation?
No, I'm not going to that.
No. Okay.
Darn. Yeah, are they sending out invitations or something like I didn't know?
Well, they delayed it because they were not ready. So I guess it's around November 30th now. Yeah. Allegedly, I don't know, but I'm gonna try to be there. So I
was amazed that I got to go to AI Day actually. So I'm happy with where I'm at right now.
But that's pretty close to you, right? Palo Alto?
Yeah.
Okay.
Pretty close. But it's a recruiting event, and it wasn't clear that anybody who wasn't a potential hire was going to get to go for a long time. I know a lot of people who really wanted to get in and didn't. So it didn't look like the odds were good for a long time. So
yeah, totally.
I was super pleased to be able to get a chance to go.
I mean, talk about an exciting way to recruit people. There was one lady who came up at the end when I was trying to talk to Elon, and she was like, I work for Google, but I want to work here. I work for Google. And he was like, okay. It's just very straight. Okay, whatever.
The number of applications they get for the number of positions they fill, the ratio it's nuts. It's like 1,000 to 1 or something like that. So they apparently, but it seems like they really, they're very serious about wanting the cream of the crop. Right. Yeah. And so having a lot of applicants is a useful thing for them.
Yeah. Thank you to Nelson for the super chat. Apparently we competed with Monday Night Football and we won. So
wow. One meaning that we lasted longer?
No,
or that they're watching us instead.
I think he chose to watch us over football. Yeah, I don't know.
Oh, okay. You never know. Because how long is the football game? Is it almost 3 hours? Is it about Friedman?
4?
Yeah,
I used to. For a while, we lived near Texas Stadium in Dallas, where the Cowboys were, and I swear it seemed like the football games went 12 hours when we lived there.
Yeah, that was all the tailgating and everything.
Yeah, Uncle Yukon Monday Night Football. What is that? I'm sure a lot of these viewers are probably not big football fans. Maybe I'm wrong. I think we can have sports.
I think some of them might be football fans, meaning European style football, or international football, but maybe not American.
Well, James, I would love to climb with you sometime. So hopefully someday you're willing to try it again.
Okay.
Okay.
I really enjoyed getting better at climbing, and when you get so good and you're kind of at your physical limits, and then it just stopped being fun for me after that. So after that, climbing was super painful, not being as good as I was in my heyday. Has been tough. So I've a couple of times I've done a little thing. Maybe we'll go. I'll belay you, right?
Yeah. Okay, so you have done sport climbing.
Oh yeah. No, I mean it was a new thing when I started climbing, but and then it took off. Everybody was doing it, and so I went to Italy and I spent a month climbing in mountains there. I used to go to Smith Rock all the time. Do all the 513s at Smith Rock. Yeah, it's super fun
So I'm curious, with you being interested in brains, are you interested in Alex Honnold's brain and how he just has this lack of fear and risk?
So I went to go do El Cap one time a bunch of years back, and we had a weather event and we ended up bailing off. But we went like halfway up, and I got to stand there for a while, and look at the valley, standing on something the size of a shoebox on a slab of granite tilted vertical, bigger than the Disneyland parking lot, and it's a really horrifying experience. I discovered, right, and. So like I have not been able, like I'm so interested in that guy's story, but I can't bring myself to watch any of the video from him free soloing El Cap. I can't.
I haven't seen it.
No, I haven't seen it. And
so
like I'm super impressed and kind of shocked that that's a thing that exists, that people can do that. Like it's an amazing testament to the variety and capabilities of human beings. I was like if you've been up there, it's just overwhelming, being on El Cap. And, the idea that some guys just like, after breakfast, I'm going to chalk up and climb up El Cap with just my fingertips is like, I don't know. It's weird, but like, I can't watch the video. I just can't do it.
I feel like you'd love it.
I think I'd be running to the bathroom and throwing up constantly.
Oh my God.
Seriously, it would be a terrible experience. So like I've just even seeing the previews of it has been really difficult for me to do. I think it's different. It's different if you've done that stuff than it is if you watch it as a third party.
Yeah. I feel like if you actually have rock climbed, you just realize, especially like how bonkers that is, that, your forearms could get pumped. Your foot could slip. Your foot could slip, it's just wild to think that he sustained that for that long. Sorry guys to get on climbing talk, but if you haven't seen free solo,
you're into it. Climbing is really fun. I really recommend it as a sport. It's great. And like, it's an engineer's sport too. Like if you're into engineering, like you have the brain to do it. Because it's a puzzle solving thing too.
Right. It's not just like, sets and reps. It's like you're solving a puzzle and trying to get the technique and the beta for how to complete this climb, and also being strong helps.
Yeah, and the dopamine payoff for when you figure out the thing, and it feels so good, right? Yeah. It feels so good to to nail, especially if you have a project you've been working on for weeks. Like it's the best feeling to finally ace one of those things. Yeah.
Yeah. So hopefully we've inspired you guys all to go try rock climbing.
It's really fun. It's really fun.
Scott tried it. You tried it.
Yeah, I did. And there was a little bit of payoff, except the next day, man. Oh,
yeah.
I really paid for it the next day.
It's hard.
It takes a lot. And, the interesting thing is, when is Optimus going to have the strength and the dexterity in the hands to be able to do something like that? I mean, that's going to be a real challenge.
Well, he's got a different set of constraints. He has latching.
He has no fear. But still.
If you have latching actuators for your forehands, you're halfway done, right? So like anything you can get your hands around, you can do it. The first few weeks is rough. When I first started climbing, I would we would go to this bouldering area. And I would be so pumped after we had a session that I would have to stick my hands through the steering wheel to drive home because I did not have the grip strength to handle the steering wheel. Like that happened to me 3 or 4 times and then you get over it, right? And like your hands get to where they can deal with it. But then your hands turn into feet. It's like Ellie's hands. Like I used to be able to if you climb at Joshua Tree out here, it's like climbing on broken glass. Some of the things, but after a while, you kind of don't hear it because your hands turn into like leather gloves, and you can climb on anything.
So Richard says this will be the true test. Optimus will definitely free solo El Capitan. So if Alex Honnold can do it,
yeah, he won't have the fear thing. It'll totally happen. Well, somebody will build a robot, but it won't be impressive. But people won't be impressed when a robot climbs it. But if you put a robot in climbing shoes and make it climb in rubber gloves or something like that, and you don't give it latching actuators, I don't know. It's so hard to say. So much of rock climbing is physical.
Yeah,
right?
totally.
That you, yeah. I guess people wouldn't be surprised. Like, I'll be super impressed.
Yeah. The thing is, whether it would need toes, whether Optimus could do it with those feet.
You know,
I don't think so.
What's his name? There's a professor at MIT. He's now a professor at MIT, and in his late teens, he got caught on Mount Washington in a blizzard, and he was a rock climber. He became a double amputee below the knee, and he started designing his own prosthetics. He's quite famous. Like, I feel bad that I can't remember his name right now. So he discovered that having prosthetic legs was actually a big advantage for all kinds of climbs. So yeah, it really was. He designed his own. He started designing his own prosthetics so that he could get back into rock climbing, and then he became like crack climbing at the time was a really big thing. It's not so popular these days in gyms, but
painful.
It's not so bad it depends on the crack. It's off-wits are pretty miserable. And but thin finger cracks and that kind of stuff, like once you get the hang of it, they're pretty straightforward. And this was back in the days when you had to place your own pro. There weren't any bolts or whatnot. And one of the nice things about climbing cracks is you can place pro inside cracks, which is really, really solid and you can trust. If you don't have those kind of features in the rocks for hanging your protection, then it's hard to relax when you're trying to climb.
I think your sister likes us talking about rock climbing. Thank you for the super chat.
She's like, my brother-in-law is a fan of your channel, so she's.
Oh, cool.
It might be him.
We love it. We need more fans because this is my full-time job now. So
yeah.
That must be exciting.
Yeah, but that is rather interesting. That I've wondered about some of the prosthetic designs that you've seen with the carbon composites that have a lot of spring back, and why they aren't using something like that on Optimus already, or do you think they will?
There are people who design, especially bipedal robots, with an eye toward efficiency and that kind of stuff, and they have these, spring weight systems and whatnot that are designed to make them efficient or self-balancing, and it's interesting. But I feel like Optimus is solving a different problem. That a lot of those problems, they don't fit conveniently inside the human form factor envelope. So if you want a robot that's a drop-in for human tasks, it becomes more challenging with some of those things.
Yeah, well, I'm just thinking about a little bit of not having such a flat foot like that, just having something that had a little bit of form or shape.
I'm sure that in time, the shapes they work with will become more sophisticated, and in the short run, let's get the degrees of freedom, have the basic envelope, and develop a platform for getting the software right. Once you get the software right, then they're going to come back to the hardware, because there's lots and lots of levels of refinement of the hardware, which will happen in time. But they want to get something out the door so they can start working on other aspects of the problem too. So they have their MVP that they can build on.
Mm-hmm. Yep.
Thank you to all the new members who joined during this live stream. I really appreciate it.
Okay, cool. So we've gone 2 hours and 45 minutes. We should probably think about wrapping up.
Yes, we definitely will. But thank you, James, so much.
My pleasure. This was fun. I didn't know what I was signing myself up for, but it turned out that we had fun.
I'm glad you agreed to the unknown. That's usually a serious thing for people.
I get super nervous. Like I'm really introverted, so like meeting new people and going on a new channel or something like that is like a total sweat-inducing thing for me. And I've gotten a little bit better at it, but today was the first time in a long time that I was like nervous all day before a show.
You were nervous?
Oh, really?
Oh, yeah. I was like, I had to distract myself with a book and take a nap and that kind of stuff.
Why were you nervous?
I guess I'm an introvert, right? And that's the way we're wired. So.
I thought you'd be like totally used to it now from Dave. Just
you would think, yeah. Apparently, there's some things that I don't learn very well. So
well, you did great. You didn't come off as nervous to me.
Thanks.
I don't think any of us thought that you were nervous.
I learned a lot myself.
Yeah, I learned a
lot. I don't know how to spell fluxinos. I can spell it. I just don't know how to pronounce fluxinosity. I believe vilification, but I'm going to have to keep playing that little portion back there to get it right.
Okay.
We'll leave on that note. Can you explain that term and what it is?
Philosonoscene, it's the act of estimating something as worthless. So as I said before, it's like if you're casting shade on something, you're engaging in philosonoscene hilopilification.
How do you say it?
Philosonoscene hilopilification.
Philosonoscene hilopilification?
Yeah, there you got it. So,
oh, wow.
No problem.
Is that longer than supercalifragilisticexpialidocious?
That's
Why,
actually
but
really,
close.
It's the same length as anti-disestablishmentarianism, so it ties for the longest like normal use word in the English language.
Oh my gosh! All right, well, one of you guys is going to have to write that so I can look it up.
Yeah, these are words.
I know how to spell it by now, but pronouncing it is still a tongue twister.
Yeah.
Well, thank you, James. I'm so glad that you didn't
My
bail,
pleasure.
considering you were like not apparently stoked on this, but you did a great job.
Thanks.
We really appreciate it, and hopefully I'll see you at a launch. Or
Yeah, that would be great. Well,
or
let's stay in touch.
I still haven't gone to Vandenberg, so
Yeah, well, give me a ring if you come out here. Like, I'll show you the good spot to watch from.
Yes, awesome. Well, great. Well, thank you everyone so much for watching on a Monday, and I guess whatever you gotta do, go do it.
Bye, everybody.
Somewhere around here. Oh, that's where it is. Yep.
Thanks, everyone.
Okay. Yep.